So it is right on the hour, depending on where you are. So I might actually get started. We've got just past 100 participants. So welcome again, if you've just joined since I last spoke. Welcome to this WCRP Climate Research Forum for the Southern Asia region. Great that you've joined us today. So I'll get started now. I'll begin actually with a few technical details just to get us going. So I've already mentioned about Slido. So I think one of our organisers was going to paste the link into the chat window as well. So have a look there, but it was also in the registration information. I'll remind you to keep your microphone and video turned off unless you're presenting or are a chair or rapporteur or we've asked you to speak. And if you need any technical assistance today, then you can chat through Zoom chat to one of our secretariat, Nico Caltabiano, who's here today, and he'll try and solve any problems that you've got. We're very keen to engage with you as best we can in this format today. So you can ask questions of the speakers using Zoom, the Q&A window in Zoom. You can also like the questions that you like, and the chairs will select those questions that they think is of the greatest relevance and interest, and we'll aim to answer as many as we can in the time we've got available. If you want to have a discussion in the chat, that's fine, but just note that we won't be monitoring the chat for questions. We'll only be looking at the Q&A for questions. And as I've mentioned, we'll also be using Slido, get some feedback from you throughout the forum. I need to remind you that we are already recording this forum. We do that to assist us with documenting the content and the outcomes of the forum. And we also post that recording on our WCRP website so that people that couldn't join us today are able to view it later. And if you've got any concerns about any of those things, please do just let us know. Okay. So I'm going to now sort of welcome us and introduce us all formally. So good afternoon, good evening, good morning, wherever you're from. My name is Helen Cleugh, and I'm the Vice Chair of the World Climate Research Programme's Joint Scientific Committee. Our Chair, Professor Detlef Stammer, is unfortunately unable to join us today, but he does send us his best wishes for a productive and successful forum. And so on behalf of Detlef and myself, of course, it's really a great pleasure to welcome you here today, and I really thank you for taking the time to join this forum. The purpose of these research forums arose actually out of when we started developing our new WCRP strategic plan. Now I see someone, Dr. Rayo, has got his hand raised. We won't be answering raised hands, so if you've got a question, if you could put it in the chat, that would be great, thank you. We wanted to engage with our broader community, both researchers and stakeholders. And if I could just remind people to mute as well, thank you. Because we wanted to strengthen the awareness and understanding of the World Climate Research Programme, as well as describing our new strategic plan and soliciting feedback. So in 2020, we committed to delivering a series of virtual regional consultations around the world with the aim to showcase some of our advances in climate science, especially some of those most pressing scientific challenges and the scientific frontiers that still need to be investigated. We wanted to explore the role that WCRP can play in shaping the climate science that's done around the world to make sure it's still relevant. And most importantly, we wanted to provide a forum for sharing information, fostering discussion, so that we can engage with the broader community. And that includes our early career scientists, as well as users of our climate scientists, because this helps build our diversity as well as ensures that we're relevant. With COVID, this needed to be a virtual video conference based forum. That meant we could do it in the local time zone of each region, and it enabled us to tailor the content and discussions to hopefully meet the needs of scientists and agencies in those regions. So here today, we are in the region of Southern Asia. We're very aware that this is a region where severe weather and climate events and climate change have a significant impact on the people, their health, their safety, your livelihoods, and as well as on infrastructure and agriculture and water resources and so on. So we hope that this forum will be of relevance and interest to you all. And so that segues me actually to describing the program that we've put together for this forum. So following this brief introduction and welcome, we'll go straight into a presentation on the World Climate Research Program, our strategic plan and our mission and our role, along with some of our key activities. And then the third session, session 3, focuses on the needs of society for climate science and information from the perspective of both stakeholders as well as researchers who are working closely with these various sectors. And you can see the presentation titles there for session 3. And then we go to session 4, whose focus is actually on the climate science that we need to do to make sure that we can address the needs of our stakeholders. And we have a series of really interesting talks showcasing WCRP's science and also some of the priorities and challenges for climate science in the region. And then we conclude with session 5, which is a short wrap up to recap on what we've heard, reiterate some of the key messages. Throughout, you'll see we've got a period set aside, time set aside for questions and answers and discussion, as well as using Slido. And there will be a very final Slido survey that will actually stay open after this forum ends. So before I go on, I would actually like to invite my colleague, Dr. Krishnan Raghavan, to say a few words of welcome. Krishnan is one of our Joint Scientific Committee members of the WCRP. He's currently the Acting Director at the Indian Institute of Tropical Meteorology, and he's the Executive Director for the Centre of Climate Change Research at the Institute in Pune in India. Krishnan, over to you.
Thank you very much, Helen, for a beautiful introduction. You have really set the stage for today's WCRP Regional Climate Forum discussion for South Asia. And so all the distinguished panelists, colleagues, and friends and distinguished participants, welcome you all. I join Helen in welcoming you all to today's event. And basically the South Asian region, as Helen mentioned in her brief introduction, has been experiencing several extreme weather and climatic events. And this has been, we have recently seen, I mean, right now as we speak, Chennai in South India and many places are experiencing very heavy rainfall. And this has almost become a kind of norm, heavy rainfall events. And we also had such events before, but this is becoming more and more frequent. Also tropical cyclones and heavy precipitation events leading to floods, and droughts also are getting severe, becoming more severity of droughts and heat waves. So clearly the importance of climate science for making robust attributions and projections at regional scale, whether these changes that we are seeing are due to human-induced climate change, or how do we separate the natural forcing. These are all inherently complex at regional scale when we, as compared to the global scale changes, mainly largely because of the strong internal variability. So the science understanding the causes for these extreme events and severe weather events and the hazards, climatic hazards, is very important, laying the scientific basis. And this in turn will be useful for developing applications and producing reliable regional climate information. So these aspects will be covered in the presentations during this event. Thank you very much, Helen. So with this, I conclude.
Thank you, Krishnan. I really appreciate that. And so before we come to the next presentation, it's very important that I provide some thank yous. Something like this doesn't happen by magic. We assembled a group of esteemed researchers and colleagues from the region to help us organise the forum and develop the content and suggest speakers. And I thank all of them and their institutions for the great way that they came together to organise today. It was really appreciated. It was fun and great working with you. We've got 2 early career scientists, Priyanka and Feba, who are going to be our rapporteurs for the forum, and I'm really grateful for them for doing this role. It's important for us as well, so thank you. And we've got 2 of our secretariats who have supported today as well. The International Monsoons Project Office at the Indian Institute of Tropical Meteorology. Thank you to Susmitha, Somnath and Rupa for your support. The WCRP Secretariat, who are mostly in Geneva in Switzerland, Hindamathi, Narelle and Nico, have also provided great support for today. And the WMO, who are one of our co-sponsors, have also provided the technology for the Zoom webinar and video conference platform and answered many of our technical questions. So thanks to them as well. So we're going to go to the first Slido poll now. So we want your feedback and we really value this. So if you can pop on over to Slido and answer the icebreaker question, which is about where are you joining us from, and already we're starting to build the word cloud up, so that's great. I'll just wait a few more minutes to give you all a chance to enter in there where you are from. It's always interesting to see what this word cloud looks like. I'm always interested to find the people who are not in the region who've also joined us, which is the joy of having an online forum. But looks like we've got membership from all around the place, so that's great. So just keep on populating that. Are we going? Looks like we've just about got everybody that registered here, so that's good. So Pune is a very popular place, but we've got researchers from my country, from the UK, from Europe. That's great. So just let you keep populating that. But the other thing that we're always keen to hear about is how aware our audience is of the World Climate Research Programme. So if you could answer these questions, it's really important for us to know about this, because we're going to have maybe 170 or 180 people join us today. It's good to know of our audience how many of you actually know anything about us and how many of you don't. And that helps us to think about how we engage and communicate in this region going forward. So really appreciate you taking the time to answer those questions as well. The word cloud's still open. I'm actually going to go to the next talk, but Hindamathi, we can probably keep this Slido survey open through my talk, and maybe we can just close it towards the end of my talk. I hope that's okay. I'm just conscious of the time. We've got a very full program today, so I don't want us to get too far behind. So I am going to go to the next session 2, which is the presentation on the WCRP, but as I said, the Slido poll will stay open. By way of introduction, I just want to acknowledge something that we all know, and Krishnan touched on it as well, that the demand for credible and useful climate information is really large at the moment, and it's urgent, and it's there across all sectors of our society and our economy, from emergency services through to health, agriculture, infrastructure, water, energy, all these sectors, even the financial services sector, they're all asking questions about, well, what does the future climate look like? And what does that mean for our business and our sector? So, and yet at the same time, there are many aspects about the climate system that require more research and more discovery to continue to advance our understanding and knowledge. And it's the World Climate Research Programme's role to advance and coordinate this climate science around the world to build this foundational knowledge and understanding. It gets used, that information and knowledge and understanding gets used in many forums, including, for example, the IPCC. So the Working Group 1 report of the 6th assessment, of course, was released in July, August this year. And much of the science that you see there is the science that's coordinated and done by scientists that engage with WCRP. This brief and high-level talk provides an overview of our strategic plan, some of our new science, some of our initiatives that we're developing, so that to support society's need to adapt to and mitigate the risks arising from climate variability and climate change. And we intend for this to be a first step in what we hope will be an ongoing dialogue with our researchers and partners and stakeholders around the world. The World Climate Research Programme for over 40 years has addressed frontier scientific questions related to the coupled climate system. These are questions that are too large or too complex to be tackled by any single nation or any single research program or even discipline. Rather, it takes a world program of scientific research to study the global climate system, including its feedbacks both with natural ecosystems as well as human systems. That includes observations, analyses, and modelling across all time and space scales, and it also must include coordination and deep collaboration around the world and across disciplines. WCRP was established then in 1980 to facilitate this coordination and advance our understanding of the Earth's climate system, especially its predictability and especially on how it is being affected by human activities. As we look to the future, the decades ahead, we recognise the critical need for climate information that can support decision-making, management of climate or managing climate risks, and supporting climate adaptation and mitigation. And meeting that need requires new science, new technologies, and especially new ways of co-designing knowledge and information. We need to be able to coordinate that effort around the world, as I've already mentioned, and engage with our stakeholders, as well as ensure that we have a prepared scientific workforce. And we need strong global partnerships because we cannot do this alone. So our new strategic plan that was launched in 2019, so it's not quite so new now, addresses these challenges and opportunities for the coming decade as captured in our vision that you can see on the screen in front of you. It also clarifies our purpose or our mission, making very clear we're not a funding agency. Our purpose is to coordinate and facilitate international climate science, to develop and share and apply that climate knowledge that's contributing to societal well-being. The strategic plan is available on our website at the link that you can see there. There's also a short movie that you can watch if you want to know more. This is an overview, a schematic that's an overview of our strategic plan. And starting on the right-hand side with our 4 scientific objectives, the first 3 around fundamental understanding, prediction of the near-term evolution, and the longer-term response of the climate system. Those 3 continue the science that we've been doing for over 4 decades. But the 4th scientific objective recognises the urgent need to better integrate natural and social sciences so that we're building a bridge between climate science and societal needs. We do this across a range of interacting space and timescales. And understanding, observing, modelling and collaborating over here on the left-hand side, these are at the very core of the WCRP. This work depends critically on our underpinning infrastructure for observations, for modelling, but also for data management and data sharing and curation, and supporting communication and outreach. If we're connecting with the wider science community, we must build partnerships. We must address capacity and education needs of our broader community, and throughout, engagement and communication are priorities. Since the launch of the strategic plan in 2019, we're very much focused on implementation, especially to identify and prioritise the research that's needed in the decades ahead to achieve our outcomes. And so a new initiative that we've launched is a series of new lighthouse activities to support and even accelerate priority research. These lighthouse activities are designed to advance some of the new science and technologies and even institutional frameworks that might be needed to meet this urgent need by society for robust and actionable climate information. These could be major experiments, high visibility projects, or infrastructure building blocks. Importantly, they're intended to be exciting and ambitious, as well as enabling us to make very rapid progress. To do this, they need to draw on WCRP's core scientific and technical capabilities, as well as our strategic partnerships. The 5 lighthouse activities that we've launched are shown here. These were launched in 2020. They all address different aspects of managing climate risk at different scales and through complementary adaptation and mitigation science. Today's forum actually features presentations on my climate risk and explaining and predicting Earth system change. So I'll just briefly describe them here because you'll get a presentation on them. So my climate risk is really starts with the decision or the user and their needs. And it will be developing a new generic framework which then can be applied to a particular region or a particular use like in a city. And that framework is all about assessing and explaining regional climate risk using all the information that it's available, not just modelling, but including modelling and all other information that's available to make climate information meaningful at that local scale. Explaining and predicting Earth system change is about building a capability for observing, explaining, and providing early warnings and predictions of Earth system change. It has a focus on much shorter timescales, the multi-annual to decadal timescales, and it has 3 themes around observing and modelling Earth system change, around integrated attribution, prediction and projection, and a 3rd theme around assessment of current and future hazards. But you'll hear more about that in a moment. What you won't hear a presentation on today specifically are our other 3 lighthouse activities. So Safe Landing Climates is about exploring the routes to climate safe landing places for human and natural systems and the pathways needed to avoid dangerous climate change, considering adaptation, resilience and mitigation, which are all complementary, of course. It takes an Earth system approach with a focus on these much longer timescales than explaining and predicting Earth system change, so multi-decadal right out to millennial. And it potentially includes social science as well as climate science. It addresses the global scale aspects of climate risk and is intended to contribute to many of the UN's Sustainable Development Goals. It encompasses 5 themes that you can see here that I've just brought up on the left-hand side. So from safe landing pathways, understanding high-risk events, as well as a focus on the carbon cycle, water resources, and sea level. The Digital Earth's lighthouse activity is the first of our 2 cross-cutting lighthouse activities in the sense that it draws on and contributes to others. Its goal is to develop a digital and dynamic representation of the Earth system so that we're really building an integrated information system that describes the past, present, and future state of the Earth system. It does this by optimally blending observations and models to develop this digital representation. And it has 4 components or activities, one around expertise in global scale, ultra high resolution modeling. That includes, model intercomparisons and benchmarking and so forth. It has a second component on data assimilation for climate models, building on our success in the NWP context and reanalysis efforts, but utilising the full power of our Earth observing networks. We want to establish regional digital Earth demonstration projects around the world in partnership and leveraging national and regional efforts. And at core are really exploiting the advances in digital technology. Obviously, this goes to high performance computing, but it also includes developments in artificial intelligence and machine learning. The second and our last of our lighthouse activities, but the second cross-cutting one, is the Academy. And the mission of the Academy is to equip current and future climate scientists with the knowledge, skills, and attributes that are needed to tackle our most pressing questions. One of the objectives is to determine the requirements for climate research education and build enabling mechanisms. It will do this by doing an annual stock take of what's available and where the gaps are, and then it will start building mechanisms, including a marketplace, to provide that training. And we're really keen, if you're interested, to get people involved in this. There's several ways you can take part in our stock take. There's the link there. If you're part of an organisation that might be able to fill training gaps, then we'll keep in touch with you. The results of the stock take will come out next year. And if you've got expertise in working with philanthropic donors or setting up non-profit organisations, you might be able to work with us as well. So please contact Narelle if this is something that you might be interested in. The Lighthouse activity science or business plans have been submitted. These are the first of their science plans, and they're available at this link that you can see here. These plans describe the science scope and objectives, some of the key partnerships, and plans for activities and implementation. A key aspect of our consultation that we're at the moment for these Lighthouse activities, we want to do this consultation and engagement right now because we want to strengthen the diversity of our science community. We want to co-design some of these activities. We want to get interest from potential funding partners. And it's also important, these Lighthouse activities are only one component of the World Climate Research Programme. So we want to make sure that we're building and strengthening our links to our core research activities. And it's to those core activities that I'd like to briefly turn to now. Because a priority for WCRP throughout our 4 decades has been, and it continues to be, to develop the science and technologies needed to advance our understanding of the Earth system. That requires a whole array of capabilities. I've listed some here. These are just a few. And WCRP has fostered and developed these capabilities and the research communities that sit behind them over many decades. And we're committed to ensuring that they endure and are sustained into the future. They are the very foundation of the climate science that WCRP facilitates and coordinates. Organisationally, they've existed through 4 core projects in the past and several working groups and panels. Those 4 core projects that have been in WCRP for many decades are listed here. Each of these have a very rich and deep array of exciting science, and I encourage you to go and look at their websites if you want to know more, because I don't have time today to go into them in detail, but you can get a flavour of what they do from this description that's on this slide in front of you. They don't exist in isolation, they work together, they have joint panels and joint projects, and these 4 core projects will continue into the future through the new WCRP. But we've also
Helen,
developing...
3 minutes.
Thank you. I'll probably go a little bit over time, so just to let you know, Nico, but I'll try and keep it to 5. We're developing 2 new core projects to really meet the challenges of the future science. The Earth system modelling and observations will strengthen and develop science and technologies for Earth system modelling and observations, but importantly, their fusion. It will unite and strengthen the work of our working groups. You've probably heard of our working group on coupled modelling, which develops our ICIMOD project, which is a very high profile project. These working groups will all continue, but the councils will cease and their work will be taken up under this new core project. Regional Information for Society is about the science and capability needed for societally relevant climate information. And it will unite and strengthen the work that is already happening by Cordex. I'm sure many of you are familiar with Cordex. You'll hear about Cordex today. Cordex will sit within this new core project, and it will take up the work of the lapsed working group on regional climate. These 2 new core projects are still under development. We are sunsetting or phasing out, if you like, our grand challenges by the end of 2022. The 7 grand challenges are listed here. Sunsetting means that if the work is ended, then we celebrate and acknowledge that. If the science still to be done, then it'll be picked up on some of the other elements. So this schematic just summarises all of these elements that I've briefly explained to you. WCRP has 3 co-sponsors: WMO, International Science Council, and the Intergovernmental Oceanographic Commission of UNESCO. And the Joint Scientific Committee, which oversees the science and direction of the World Climate Research Programme, in essence reports to those 3 co-sponsors. At the heart or core or foundation of WCRP, we have our core projects that I've already described. And we have our new Lighthouse activities, which are cross-cutting and draw on the expertise that sits in these core projects. The entire WCRP and especially the JSC are supported by our Secretariat, whose base is in Geneva, and each of the core projects have an international project office that helps with our facilitation and coordination across WCRP, as well as supporting the individual core projects that they're set up to support. Each of our core projects and lighthouse activities sponsor jointly or on their own a whole array of activities like what you can see here. So this is the timeline. I'll keep this short given the time constraints, but just to say that we've been transitioning to the new WCRP since around 2019. It's been a soft transition and it's proceeded in 3 phases. A consultation phase in 2019-2020, although honestly, we're still there. A design phase where we've been designing the new elements and refining and assessing the ongoing elements, and planning to transition the science that is being done that won't continue in the longer term, like the grand challenges. And now we're very much in an implementation phase. Our new structure is in place. We're continuing to consult and engage with the broader community and consolidating these new activities. The new WCRP will be fully running later in 2022, and in 2023, we will have our Open Science Conference to both launch the new WCRP, but also to celebrate the achievements and that we've delivered over the decades of WCRP. I'll keep this final section short because I'm going to come back to it in session 5, but it's really about stopping talking about us and talking about you. We are here to support our partners and sponsors and collaborators because you're so important to us in developing our joint climate future. We want to continue to work with you towards our common goal of ensuring that our knowledge and science is accessible and relevant. We need the best minds across physical climate science, social sciences and beyond. We need our next generation of researchers and leaders to work with us as well, and we need to build strong partnerships. So we know that we need to continue to build better ways of connecting with you during and after this forum. If you want to connect with us, the last slide will give you the links. You can help actually shape our future, and we welcome your feedback. We want to say a huge thank you to all of our sponsors and nations who have supported us so far, and invite you and welcome you to continue on this journey with us. So I'll just skip that one because I'll come back to it and finish with this. So if you want to get in touch with us at any time, here's how. We're keen to keep engaging with us. You can email us, register for our newsletter. There's a couple of links there. Register for these forums, tell us what you're interested in, and keep an eye on our website for updates. But for now, I'm going to end and hand over to our chair for the next session 3, which is Dr. Mandira Singh Shrestha, and she will take us into session 3. So thank you, and I will stop sharing my screen.
Well, thank you, Helen, and a very good afternoon to you all. I'm delighted to be here and chairing this very important session on integrating societal needs for enabling science into action. Now, when we talk about, enabling science into action, we actually need to bring in a number of stakeholders, both the users as well as the providers, into a common platform, just like we are doing now here at this forum, so that whatever information is being generated is also looked into in terms of customizing it for the needs of the users. Now, there are a number of different sectors, as we are all aware, for instance, the disaster risk reduction sector, we have agriculture, we have tourism, water resources, health, which is very important for the time being with the pandemic, which is very much profoundly being affected by climate change, and for which climate information, reliable climate information, timely climate information is essential. So this particular session here is, we're looking at it in terms of the user perspectives, in terms of the science knowledge that is being generated. How does it translate into useful information and products that are catered to the needs of the users? So in this session here, we have 5 speakers. The first speaker would be talking about more the disaster risk reduction scenarios and situations in the region in South Asia. And then we have 3 sector-specific speakers on general climate services, the regional climate services, and the activities that has been done so far, the agriculture sector, And then we also have the water resources sector more linking it to the last mile in terms of the farmers' needs. And then finally, in this particular session, we have the WCRP My Climate Risk Lighthouse activity presentation, as was mentioned by Helen in her presentation earlier. So these would be the 5 presentation speakers that we will have in this session. And followed by that, we will have a round of discussion. So if you have any questions, please do put it in the chat, which will be then taken up by the presenters at the end of the session. So I really urge you to please place your questions there. So without further delay, this session, of course, is about an hour. So without further delay, I would like to request our first speaker, Professor Dimri, AP Dimri, and he's from the Jawaharlal Nehru University in Delhi, India, for his presentation on the disasters in the Himalayas. So over to you, Professor Dimri, and kindly share your screen.
Yeah, thanks, Mandira. I hope my screen is visible to all.
Yes, it is visible.
Yeah, thanks. Yes. Okay, so thanks, Mandira, for introduction and in extension to Professor Helen and Professor Krishnan's remarks and the thought which we churned during our initial meetings. So I'm limiting my discourse in disasters in the Himalayas, what we know with the changing time, how these disasters are moving from understanding in the complex processes which is known or not been known. There could be many. I am not talking of earthquake primarily because that is more to do with tectonics, slippages of fault and plain. But of course, we know there are many type of disasters leading to impact the societal benefit coming over the region. Even I'm not including the bad AQI at Delhi right now, and because of the various forcings in and around the region of the South Asian continent. Cloudbursts are a very prominent region of the disaster, what we saw in the last decade. And it is a very complex phenomenon. Unfortunately, these disasters, whatever we are talking in the Himalayan region, they are only reported in the societal framework when they are affecting the downstream society. Else, there are very least observations of these disasters coming from the interior of Himalayas, maybe the forest fire, glacier lake outburst, even avalanche is the another disaster which is getting preponed for, which is getting very importantly taken into care for the defense purposes as well as the tourism purposes, academic purposes, and various other purposes. And another important is the extreme precipitation leading to the floods in the various rivers. So now the Himalaya is very less monitored if you talk of the southern rim of Himalayas. And then if we want to know how much snow falls in Himalayas, in particularly over the winter time and as well as the summer time. And then primarily starting with this, I would like to tell then how the processes of this precipitation forming processes as associated extreme events, how they are kind of linked to the smaller scale to larger scale phenomenon, how the processes are getting exchanged. With this, if you see then, and then with the modeling experiment, if you look at that with the annual trend of monsoon, encroaching monsoon, precipitation encroaching inside the Himalayan region, it is a very vivid, not so well-defined picture. Some of the regions we find the trends are increasing of the monsoon precipitation, some of the trends are decreasing of monsoon precipitation. I am not going into detail of the processes, and I am also not going into the detail of the orographic interactions because within the Himalayan formation also we have kind of a tectonic mountain, and the foothills of Himalaya is not the tectonic mountain, it's the sedimentology mountain, which we call popularly as the Shivalik, or maybe the and then how these interaction with the Himalaya with the ongoing monsoonal flow interacts in different model environment represent very different picture of the annual trend of last 30 years over the monsoon. And we distinctly see in the northeast region primarily, it seems that Himalaya is no more intruding inside the northeast region, and it's moving more towards the western side as far as the Himalaya is concerned. Maybe it is to do with the energetics of the monsoon dynamics, which I'm not touching upon here. And then if you look the elevation dependent distribution of the precipitation, definitely the lowermost elevation of the precipitation forming process is more in the elevation with 500 to 100,000 meters, right? Where a lot of the interaction, which is more non-linear in the context where most of the disaster happen. And as the flow goes up in the higher elevation of the 6,000 meters or 5,000 meters, we found the clusters are much closer, and the process of Himalayan distribution of precipitation in the vertical elevation is very, very distinct. But what I would like to highlight one point, if you look at the mid elevation region of 300 or something like that, we found that there is somewhere threshold, the precipitation forming physical process or mechanism over the Himalayan elevation gets reversed or changes roughly 3,000 meter or something like that. Second important point, if you look at the scatter blobs here, we find that in model, the lower precipitation range events are much easier to capture in the modern environment. But as we go to the higher events, with higher precipitation millimeter per day in observation, model is unable to capture that. Model physics has not been able to capture the higher precipitation events. So that is the very tricky point, that how the higher precipitation events are not being able to capture in the model in that sense. And in view of that, that's very tricky, that how the cloud-burst type of event, I will talk of with one case study. Second, importantly, we have collated 1800 onwards the extreme precipitation events on this. And if you look at the yellow dots here, we try to make a cluster analysis. Very intriguingly and interestingly, you will find these all extreme rainfall events, which we see over these regions, roughly between 1,000 and 2,000 meter elevation in between, and they are not going beyond. So two things are very distinctly clear. I am not going into the debate of the two-step topography. It is very distinctly clear that the precipitation forming mechanism only able to pull the extreme events up to 2,000 meters elevation and not beyond that. So that pull to the extreme rainfall events along the southern rim of the Himalaya is very interestingly to be seen, that why there is extreme rainfall events are limiting to 1,000 or to 2,000 meter elevation belt and not beyond that. Of course, there is certain cloudburst cases where it goes. And then we try to look at how the forcing leading to the elevation dependent warming in the winter and different monsoon and the season. We found very intriguing trend that during the monsoon time as well as during the winter time, if you look at that, all the seasons, of course, monsoon, you have a very vertical distribution of elevation dependent warming as well as elevation dependent distribution of precipitation. Due to the dampening of moisture in the monsoon time, we don't see much difference on the monsoonal distribution of the temperature, because moisture available in the free atmosphere dampens the variability of temperature. But in the winter time, we find the warming rate and the higher reaches of the Himalaya is more. I mean warming rate, not the warming. So 5,000 to 6,000 meter elevation in the Himalaya is warming rate is higher in the last 30 years as compared to the lower elevation, where we see the variability of precipitation is more as compared to the higher elevation point. And that's where we look into the available various forcing, that 3,500 is the elevation point, where 3,500 meters. Beyond that, the characteristic of the processes are much, much different. And above that, the characteristic of the processes of the warming as well as the cooling is differently, very distinctly different at 3,500. And that's where the very critical edge of the understanding of the mountainous processes is need to be understood. Another important,
3 minutes.
Yeah. And another important point is the south, we have to have a slope environmental lapse rate. Slope environmental lapse rate is because in the mountainous region, we don't have a very successful vertical atmospheric lapse rate working there. We have to reconsider the slope environmental lapse rate. That's where if you look at the ridge valley system in the mountainous region, we don't have the slope environmental lapse rate, particularly in the Himalayan region, where various effects are coming, cold arid region in Ladakh, Dras, Kashmir, and hence we have a slope environmental lapse rate coming into the picture. And there is an extreme flow in the Western Himalayan region. Maybe the Subimal is here. He will be able to give more emphasis on this, how the precipitation melting of the snow glacier and contribution from monsoonal precipitation in coming years, few years, decades time is doubling the monsoonal precipitation. And that's where the flood is very critical in the mountainous region. We have various floods coming associated with the monsoonal outbreak, as well as the increase in the precipitation happening, land use, land cover in this region. And hence there is an overall change in the ratio of the snow and precipitation over this region. We could see that the mean water snow equivalent in the 30 years time has comparatively changed over these, all the basins which are associated with the southern rim of the Himalayan region. And in case of cloudburst, I would like to say that the precipitation, as I told, doesn't go beyond 3,000 meter general climatology. But in case of the precipitation, which is in case of cloudburst, it goes up to the system is going up to the 14 kilometer in the vertical height in one of the experiments which we have seen. Here I am talking of the landslide associated with the March, April, and October and May, where you will see the red color is with the May, September associated with the Indian summer monsoon, and the blue color we see during the winter monsoon. We analyze along the slope how the landslide, and we saw that landslide in this case has increased over the region for the various kind of precipitation. And particularly this slide comprehensively tells us that the disaster in the mountainous regions are no more in the isolated manner. Primarily the disaster what we see in the Indian southern rim of the Indian Himalayas, they are becoming cascading in nature. One disaster initiates another disaster, and it's a kind of a disaster which are coming together. Maybe it's a kind of a rock fall, it can be a kind of avalanche, it can be a kind of flood, and then these kind of a disaster is integrating to the other disaster and next disaster, and that's what is leading to many kind of formation of disaster, which is ultimately leading to the downstream development of the panel of the dam, society, and many kind of another issues. So these disasters are very critical in that formation over this region of the Himalayan region, which is very key to look into the policy planning. Now, these observations which are here needs to be looked from the policy and planning point of view, where in certain cases we see that these things are going into the development of the early warning system. In case of flood warning, we saw that in the Himalayan state that had been taken into care about the flood warning system. Certain incidences which were associated with the religious pilgrimage in the Indian subcontinent, they were also taken into account, how that disaster can be minimized in case of certain future events of disaster happens over these regions. And then there is a kind of a guideline and policy have been made in case of the central Himalayan states of the India, that they have a kind of a guideline how these could be reflected in the policy and planning. So with this, I thank you for, okay, this is the another GLOF. We have looked into the GLOF, how many GLOF events are within the Indian subcontinent and how many are across the transboundary GLOF. This analysis we have also done in the purpose from the various potential trajectory of the, if in case of the GLOF one breaks off, and what will be the potential disaster to the downstream population if it happens in the future. So with this, we are can kind of plan certain kind of a disaster pattern over the region, where we can see that how these could be minimized for certain sector, at least to begin with. And primarily when this happens in the free kind of atmosphere and climate and intersection with the various sections of the climate, land use, land cover, rockfall, or the loose soil, how these disaster patterns can be arrested in advance. Thank you very much, Mandira. I'll be happy to have questions in case if there are any.
Yes, thank you very much, Professor Dimri. Indeed, a very insightful presentation. And I'm sure there would be plenty of questions. I was just wondering, in fact, a quick question comes to my mind, but regarding predictions, but we can take that later, I think. I'll also request all the participants to please hold their questions and kindly note it in the question and answer box here. Now, making sure that we are on time here. Let us, move on to the sector-specific perspectives. And here, the next presentation title is Regional Climate Services Activities for South Asia, and that's Status and Future Plans. And providing this presentation, we have Dr. D.S. Pai, a very prominent scientist. We are fortunate to be having him here today from the India Meteorological Department. So over to you, Professor Pai, and you have roughly about 7 minutes.
Thank you, Mandira. So I will be speaking on regional climate service activities, its status and the future plans. Is it changing my slide? Okay. So basically,
yes.
Basically, I will be explaining activities of Regional Climate Center of WMO situated in Pune. So from these services we have been providing since 1995, but up to 2013 we were mainly concentrating India-specific services. But from 2013 we started working as a Regional Climate Center, and we got recognized in 2016. Since then we have been doing all the mandated activities of Regional Climate Center for South Asia. So this is the website that you can get. We actually performs all the following mandatory functions covering domains of long-range forecasting climate, climate monitoring, data services, and the training. So you can see that all these mandatory services are being provided, and our important products are like global monthly and seasonal forecast anomalies, both rainfall and temperature, and which is updated every month. ENSO and IOD forecast bulletin being updated every month. Seasonal forecast outlook for rainfall and temperature, again for South Asia, and it being updated every month. And one of the main activities is for South Asia Climate Outlook Forum, where we provide consensus forecast of seasonal climate forecast for South Asia for all the important seasons. And in addition, it is being supported by extended rain forecast of rainfall and temperature for the next 4 weeks. And also we provide other products like IMD and data assimilation analysis, reanalysis by NCMRWF, and also high resolution simulations of 20th that also can be available in that on our website. And basically we use monsoon mission coupled forecasting system to generate the long range forecast. So this is, as I said, one of our main activities, South Asia Climate Outlook Forum. We basically concentrate on Southwest monsoon season, Northeast monsoon season, and winter season, because these are the main rainfall season for our region. And we concentrate mainly for rainfall and temperature forecast. And we also, with the support of several regional and global centers to prepare the climate forecast, like UK Met Office, RIMES, IITM, and NCMRWF in India. And these are the 9 countries which actually involved in this activity. So basically, when we prepare the regional climate, just for how it was evolved, I will tell you briefly. We started this activity in 2010. So in that time, we did not have much capability in many of the countries in the region. So we had in the 2010, when we generated forecast outlook, basically initially for Southwest monsoon season. In the first year, our forecast was consisting of only rainfall forecast for the South Asia as a whole, and no forecast map was generated. And subsequently in 2011, from 11 to 15, we started providing forecast map depicting areas of most likely terrestrial category. You can see like yellow below normal, green normal, and above normal, like that. And from 2016, meanwhile, we also started extending the services to other seasons. And from there onwards, from 16 onwards, grid-wise terrestrial category was started giving. And this was derived from initial set of gridded objective forecast based on blending the grid point forecast prepared by various individual national meteorological and hydrological services using various dynamical, statistical, and hybrid methods. And we generally ensure that at least 50% information comes from the dynamical models. And during this period, we also had trained all the people from the other countries to generate this kind of forecast. And based on the guidance of the WMO, that we started generating objective seasonal forecast from this year based on multi-model ensemble of coupled climate forecasting models from various centers. And we found that these models show you much better skill than the earlier method. And as of now, we basically mainly use coupled, coupled models only to generate MME, and there is nothing other type of intervention is not there. So it's basically it is given objective seasonal objective method is being implemented. And
you have 2 minutes.
Yeah, it's the last slide. Okay. So this forecast which we have been generating with the help of agencies like UN ESCAPE, we convert them as an economic impact based forecast from the SASCOF. So for example, you can see that this was generally generated by ESCAPE of based on SASCOF outlook for 2020, both for monsoon season and post monsoon season. And basically this gives you exposure data and our forecast, basically rainfall forecast like above normal, below normal, and various exposure like water stress and malaria incident rate, hydropower plants, etc. And along with that, vulnerability indices, it can be converted as a impact forecast. Also, an example has been given. This document which you can get from UN ESCAPE website. Finally, coming to conclusions, we have made a significant improvement in the seasonal forecast in the region. But however, we are finding that still when you go for a smaller region and smaller time period, and when you go particular smaller countries, skill is still not so good. So there is a need a significant improvement on that. And development of MME tools for generating LRF products, both rainfall and temperature. That is our future plans for not only India as well as for other South Asian countries. And it's not limited to only important season. This will be becoming updating monthly every month and for all the seasons. That is what we are planning. And also a supplement seasonal forecast with extended forecast. So that maximum utilization of seasonal forecast can be done. And finally, co-producing sector-specific tailor-made climate prediction product, including impact-based forecast. Like example I had shown you, like ESCAPE had done one example, but we want to do with the help of various user forums and various stakeholders continuously to co-produce, so that ultimately the seasonal forecast outlook being used by all the sectors. Thank you.
Thank you very much, Dr. Pai. Indeed, a very interesting presentation, particularly looking at some of the use of the products. Actually, the example that you give on consensus forecast on the SASCOF and how that is being translated into useful products by UN ESCAPE into looking at, say, impact-based forecasts and more on looking at the economic impacts. Yeah, I think that would be very useful. And I'm sure the participants here would like to know more about it. But I will proceed with the next speaker. Please put your, again, questions in the question and answer chat box. So now I would like to request Professor Dr. Tehmina Mangan. She's from the Faculty of Agriculture in Pakistan, from the university there. And she is going to make a presentation on risk assessments and vulnerability analysis for food security, particularly looking at the agriculture sector. So yes, over to you, Dr. Mangan.
So thank you very much for giving me opportunity to talk about this risk assessment and vulnerability analysis for food security. Just a minute. It's difficult to video. Yeah. So I will briefly talk about risk assessment and vulnerabilities analysis for food security, particularly with reference to climate change impact on agriculture Next, please. Yeah. So we know that agriculture, climate change is the biggest threat to food security, and as 85% of the world's population and 50% of the South Asian countries' population live in the areas which are highly affected by the climate change. And 60%, more than 60% world population and 70% of the South Asian population depend on agriculture for their livelihood and income support. So as agriculture sector is highly vulnerable to climate change risk, therefore they all people are affected by the climate change risk, and that huge population is losing their livelihood resources. If we want to reduce, and what we need to look at that, what these things are happening. These things are happening due to the uncertainty of the outcomes and hazards that are happening in the current time and that will happen in the future. So that uncertainty increase risk, and if we want to reduce uncertainty, we need to we need to reduce uncertainty in order to reduce risk to climate change. And uncertainty can be reduced by improving information base, by the assessment of climate change impacts, by providing data and by providing information about the intensity of this uncertainty, risk, and exposure to climate change impacts. So if we have that information, we will be able to improve our situation. We can plan in a better way and could get a solution to the climate change hazards. Second, next, please. So with reference to, as I was, the time was so limited, so I have made a few slides for my presentation. Types, if you talk about the types of climate change impacts on agriculture land, there are various types, but few and very important are agriculture impact of climate change on agriculture production, socioeconomic factors, and environmental ecology. And how these, for example, agriculture production is impacted by the change in climatic condition to the crops, increased demand for irrigation, floods, and different hazards that impact agriculture production. And similarly, socioeconomic factors are also impacted by the changing in farming institution, implementation of agriculture facilitation, evolution of agro-processing industries, and environmental ecology, and that biodiversity is also highly impacted by the climate change impact. And overall, if we see the look at the overall impact, this affect the agriculture productivity, and that finally leads to food insecurity. Next, please. These are the few impacts that are shown in this figure, that how climate change impacts on other resources, and how they are actually all resources are that are agriculture based resources. They are interlinked with each other. When climate change is impacting one resource, it leads to another hazards. Like if land degradation, climate change increase land degradation, it will increase reduce soil fertility and reduce crop production, all these things. So these are the various scenarios in which food security and nutrition is affected, and intensity of climate change is increasing. Next, please. So most important thing is why we need to look at the vulnerability. We need to assess vulnerability. To me, main purpose is to assess vulnerability, both current and future, in order to improve adaptation and planning to reduce climate change risk, and plan different instruments that can help us to overcome climate change impact. And there are various kinds and characteristics of vulnerability that might be multidimensional, dynamic, scale dependent, and physical, economic, environmental. So we need to look all these aspects in order to overcome and assess properly climate change vulnerability. We also need to look at the—
You have
Sorry.
2 minutes, please.
Yeah, relationship between, in order to assess the vulnerability, we need to look at the relationship between biophysical and socioeconomic determinants, both at current and future state, and there are different indicators for that purpose that are showing here. Next, please. And there are some stages we need to go through in order to assess vulnerability. First of all, we need to scope the study. What are the issues and objectives? What are the vulnerabilities at the moment, and how to, what things should be adopted in order to initiate adopting strategies. And there are different types of methodologies we can adopt. Agriculture vulnerability to climate change is manifestation of agriculture sensitivity, exposure, and adaptive capacity. If adaptive capacity is decreasing, then vulnerability will increase, and it will again increase to sensitivity and exposure. So there are different indicators of sensitivity, exposure, and adaptive capacity if we want to estimate vulnerability. Next, please. So risk assessment is also important. This for risk assessment, we need to look at the risk management. First of all, risk assessment, and then risk management. Then the risk management involves policy alternatives, and then risk communication to the pupils who are affected by the climate change. Next, please. In order to assess vulnerability to climate change, we need to adopt methodological approach, integration, natural and social sciences, policy focus, time horizon, special value degree of stakeholder involvement, and various approaches are needed to adopt. But most important are socioeconomic approach, biophysical approach, and integrated approach. Next, please. Framework, in order to initiate assessment strategy, we need to look at, first of all, we need to select framework. What type of framework is appropriate for that particular risk assessment or vulnerability assessment? Then based on that framework, we need to establish climate change scenarios, baseline scenarios, and future scenarios. This is an example of impact and framework for the vulnerability assessment of agriculture sector. Next, please. Various methods of are used for estimating climate impacts on agriculture production, like GIS methods, statistical models, process-based crop models, economic tools that includes various economic estimations, a contingent valuation, and willingness to pay, and different things, and household and climate change village model as well. And drivers of agriculture responses to climate change. If you look at that, here are some examples that I've taken some studies. If we look at the climate change related factors related to agriculture production, food security, that's like sea level rise, precipitation, heat stress, and what are their direction, what is their intensity. Now, what is the final consequences? So these are the type of scenarios that needs to be established for the assessment of vulnerability. And these are the example of socioeconomic impacts that help us to understand uncertainty level, expected intensity in future and current, and then other impacts. Next, please. And similar is the biophysical impacts, change in growth of conditions and all these things. So in order to and this is my last slide. And in order to estimate vulnerability, the various methods are used, but the most recent method is representative agriculture pathways, and our CP and SSPs are part of that representative agriculture pathway. They are interconnected, and this is actually based on the stakeholders' involvement, and with the consultation with the stakeholders, we develop scenarios and assess the impact of climate change and intensity of vulnerability in the current stage and in the future. For example, 50 years after this time, we can estimate vulnerability of the affected people. Thank you very much.
So yes, thank you very much, Tamina. Very nice presentation indeed. A real concrete example in terms of using of climate change scenarios and looking at the food security aspects and looking at vulnerability. Now, I think I will proceed with requesting the next speaker right away. I'm sure you will get a number of questions for your presentation. So for this the fourth speaker that we have today is Professor Subimal Ghosh. And Professor Subimal Ghosh is with the Indian Institute of Technology, Bombay. And today he is going to share with us his work on irrigation water management using weather and extended range of services. So this is what I meant about reaching down to the farmers and the end users. So over to you, Professor Subimal Ghosh.
Thank you, Dr. Mandira. May I request Professor Mangan to kindly unshare, and I will start sharing the slides.
Okay, thank you.
Yeah, thanks. I'll just quickly start sharing. I hope the slides are visible. Yeah, so I'll be talking about one of the worst affected sector by climate change, which is agricultural sector, specifically over the Indian region. And this is the work which has been done by my student Atrija Roy in collaboration with Professor Raghu Muktagudde from University of Maryland. And also we have developed these kind of models with the help of the farmers. So essentially it's a co-production of the models. And Parag Narvekar is someone at Nasik who was actually leading the farmers group, and he helped us. He actually represented the farmers group. He provided us a lot of information, and through him actually we connected the farmers and developed this kind of models. So before starting, why agriculture sector is under stress in India? Because we know that the temperature, we know there has been a huge population growth that results into problem in food security. So we need to intensify our agricultural activities, but our temperature has been increased. We need further more water. But what is happening? There has been a weakening of monsoon rainfall, increase of drought, because of which the availability of water has reduced. So we need more water, availability has reduced. So you have to go for irrigation. And most of the time we are going for groundwater irrigation, and sometimes it's uncontrolled. That's one of the major problems, it's uncontrolled. So because we are not really monitoring soil moisture, and so there is uncontrolled irrigation, and that results into groundwater depletion. And when there is a groundwater depletion, every year you need actually, for the same amount of water, you need more and more energy. And that will again affect the irrigation cost, and that will affect the food security and so on. So we are actually in a trap. And to come out of this trap, one of the solutions should be how can we better manage water for irrigation water management. So in considering that, what we thought is that we started discussing with the farmers, and we have realized that IMD has made a lot of improvement in terms of weather forecast, extended range predictions. But when we started talking to the farmers, we have found that very, very few farmers really follow this forecast. They understand it's useful, but they don't know how to use it. So we thought of, let's work with the farmers and try to develop a model in some way so that the farmers can find usefulness of this kind of forecast. So the idea here is that we started with a weather forecast. So the key philosophy is something like this. We know that weather forecast will not give you the exact information of tomorrow's rainfall or for next 3 days rainfall. But given a weather forecast, from the hindcast, we can generate rainfall distribution, and from there we can generate multiple rainfall scenarios. And at the same time, let's see, if we have a soil moisture sensor, then what we can do, we can actually apply a Monte Carlo simulation, and we can get a distribution of soil moisture. Now, this is a big optimization model, which is a stochastic optimization model, but the decision variable, how much water you need to apply. There is a farm scale eco-hydrological model. Remember that large scale models like BEAC or SWAT, these are not really useful for farm scale irrigation water management. For that, you have to understand the farmer's point of view, and then you have to use the conceptual hydrology to really develop this kind of model, which we tried to do. And then what we tried to do, because it's a stochastic model, we have put a probabilistic constraint that if the root zone soil moisture is less than a threshold soil, I mean, we are making sure that with a probability of 95% or 90% or 85%, that the root zone soil moisture is below the soil moisture threshold. And this can be given by the farmers. And so higher the values means higher water you have to apply, lower water means lower amount of water, but there is a chance of little bit of lower yield. And then we are trying to find out what is the optimized amount of irrigation water that is needed. So we try to do is something like this. We try to do, let's say, if you have to irrigate tomorrow, and if we irrigate once in 3 days, what is the amount of water needed? If we irrigate once in 7 days, what is the amount of water needed, so that for next 7 days there will be no water stress. So that's the way we try to develop the model, and we applied at the Nasik, which is famous for vineyards. So we contacted few of the farmers who are actually educated farmers. They have bachelor's and master's degrees. So we wanted to talk to them, but even those educated farmers also, they're not really following the weather forecast or extended range prediction. So when we talked to them, they told us that they do not know how to really use it. And then we started talking to them, we started developing the models with them. Sorry. Yeah, so this is the, I'm not going into the details of the mathematics. So this is a simple water balance at a very farm scale. So we are really considering at a farm scale, at a root level, what exactly is happening. So I'm not going into details of the equations. Only I'm trying to say is that RT is the rainfall, which is taking the probabilistic information. IT is the decision variables that takes care of irrigation. This is the evapotranspiration, and the leakage and the runoff, we are considering it together. So this is a model which was initially developed by Rapporteur and Idurbe, and we have further modified it for the grape condition. And this is the
you have 2 minutes.
Yes. So this is the model which we have developed. I'm not going into details again, but this tells us this is a very complicated model of hydrologic model, and outside there is a decision variable and there is a stochastic optimization model. Most interesting part what we have found is that we also tried to talk to the farmers and we tried to understand what is their logic or in what way they apply the irrigation, and we compared with their method. And what we showed is that even with 95%, you can see that we can save water up to 20 to 30% without much loss in the yield. Only for 95%, for certain cases, you are finding a little bit of loss in yield, but once in 3 days or once in 3 days, or even for 75%, you can see 40% water saving is possible without any loss in the yield. So you can see that yield keeps on increasing. That shows that yes, this kind of things are really important. Then the farmers were very interested after seeing this, it's working. They wanted to say that, okay, for tomorrow I have to plan for irrigation, but I do not know what will happen. So let's say I do not have the arrangement of water, how to do? Can we get this information 1 week ahead or 2 weeks ahead? So for that, again, we started using the extended range, but we tried it in a different way. Given the limited ensemble, which is available from extended range, we have used the weather generator to generate thousands of ensemble, huge number of ensembles we generated, and again, develop this kind of model with 3 weeks in advance and with the same kind of irrigation model. And what we are finding is that you can see that for most of the cases, again, if you consider 75% or 50%, we are not really losing the yield. We're losing the yield by 2%, even less than 2%, but we are saving a huge amount of water. Even 20% of water can be saved. And sometimes we are not at all losing the yield, and at the same time, we are saving water. So it shows that this kind of things are really, really useful, and they are kind of very happy with this kind of methods, and they're, because it's a participatory model, so they are kind of very interested in using this kind of model. We have to demonstrate that it works in this way. And the same thing for different sites. So now our next plan is to, once we have this farm scale, but if you go for a taluka scale, we have farms where we have sensors, we have farms we do not have sensors from different crops. So we are trying to use an AI/ML kind of approach where we are merging satellite data, sensor-based data, and crowdsourcing to come up with a soil moisture map. And from there, we can generate, for each individual farmer, we can give the irrigation advisory. And once we have this taluka scale, then we can upscale it to district scale and find out at different taluka level what is the irrigation water requirement, what is the agricultural vulnerability, and we can think of distribution of water at different taluka level. So that's our next plan to to really make this working at a smaller scale to larger scale. Thank you very much for your attention.
Thank you very much, Professor Ghosh. Indeed, a very interesting presentation, particularly taking into the farmers' information and then checking it into your model and seeing how best it performs. I think there's a lot of potential to really outscale it. I see that could be an opportunity for other regions and areas to learn from. But without further, I'd like to thank you for your presentation. Now, without further delay, I'd like to now go to our next speaker. And our next speaker is no other than Dr. Sachi. We call her Sachi, Dr. Trong. She's from the Himalayan University Consortium. She's the program coordinator there. And she's with the International Center for Integrated Mountain Development, ICIMOD, and my colleague. So she is going to be talking today about the WCRP My Climate Risk Lighthouse activity, more from a stakeholder perspective. So we're eager to hear from you, Sachi, so over to you.
Thank you so much, Mandira ji. Greetings from Kathmandu, Nepal. Let me start by a submission that risk, climate, or otherwise are parts of a lived experience of local communities. So is the local knowledge, understanding and perceptions of risk and practical ways to prepare for, adapt to, and rebound from disasters. Students coming from these communities into climate research find themselves puzzled at a crossroads, that between their embodied knowledge and the objective scientific knowledge produced elsewhere. While reflecting on the knowledge gaps in transdisciplinary research, there are, to me, two types of gaps. The gaps in the knowledge itself, what we know and we do not know, and the gaps between knowledge producers or holders. Yet, should we first ask, who are there in the we, before actions by whom and for whom? The two types of communities my job allows me to interact with are local community and community of researchers. For the local, the Tibetan Buddhists, for example, live in a natural landscape marked with religious significance. Tibetan sacred sites have enormous ecological significance. You could say that they are embedded in eco-spirituality. The relationship between human being and their dwelling and natural resounding is ritualized. Local knowledge and collective memories about climate variability are embraced in religious texts, and the beautiful material manifestation such as textile scrolls, wood carvings, and cave paintings, and performed in seasonal rituals. With all due respect to my co-panelists and scholars working on vulnerability assessment frameworks, telling the communities who live at the foothill of a glacial lake or in the downstream of a river basin that they are vulnerable may not help so much. They may not have linguistic terms of climate variability and may not be aware of a rising trend in extreme values and frequencies of temperature-based indices. There exists, nonetheless, a rich reserve of personal and collective wisdom, lifetime experience, and collective memories of extreme events and the loss of crops, diseases, famine, and the times of great sorrows, and how the community would cope and bounce back. If we are to make climate science relevant to the people of these communities, there must be ways to listen to and hear from them and bring their knowledge, oftentimes stored in folklores and oral traditions, into the knowledge co-production, as the previous speaker, Subiman, demonstrated. Climate communication is not just climate scientists sending messages of their findings to society. It should also be the other way around, which in turn would start with an attitude. For the second type, academic community, researchers in our consortium are rarely exposed to inter or transdisciplinary opportunities. Their university campuses are disciplinary based, School of Social Sciences, College of Natural Resources, Institute of Engineering, College of Language and Cultural Studies, etc., and dispersed not only across the city, but the country. It would take not 2 hours, but 2 days, sometimes 5 days, to reach other colleges that can only reach by road. Even when the need for interdisciplinary research is recognized by scholars in our region, it is always easier said than done. Take, for example, our own efforts in forming and sustaining a thematic working group on climate change. Under the generous support of the World Bank South Asia Water Initiative, SAVI Phase 2, an institutional seed grant was given to a partnership built the capacity of researchers in Afghanistan, Bangladesh, Bhutan, India, and Pakistan. Researchers, male and female, climate scientists, and social scientists, the latter includes gender and governance, jointly developed a proposal submitted to an external funding call, unfortunately without success. For 2 years after the completion of the seed grant, the partnership did not reconvene and would almost fizzle out. It would have been a classic telltale of donor and supply-driven intervention without a lasting impact. Meanwhile, some most dedicated member of the same group realized interdisciplinary would not take place by just putting scholars of different sciences in the same room. We then fortunately encountered the physical climate storylines approach put forth by Professor Theodore Shepard and others. The public lectures by Professor Shepard gave to HSC community attracted researchers in climate science and environmental economics to the storylines approach, but it sparked a debate, at times with a fair amount of discomfort among the audience of historians and anthropologists about the others discipline or the entire different way of knowing. It was, in hindsight, an opportune moment of conjunctures between physical storylines approach and the recent ontological opening in social sciences and humanities, where interdisciplinary proves not only possible, but indeed doable. From these much needed interactions came a desire to apply the storylines approach to the HKH, involving vastly different ways of knowing. The previously dormant climate change working group has now transformed itself into HUC My Climate Risk. It is still in its nascent stage of exploring possibilities. Yet the recognition of the importance of genuine dialogues within and between disciplines and the need to engage society in the co-design and co-production of consequential, actionable knowledge for a meaningful change marked a clear difference between this renewed group and its predecessor. It is demand-driven, member-led, self-operating, and based on resource pooling. No one just gives and no one just takes. The partnership transforms from within. Lastly, this is my last point, just 1 more minute. Since the title of our session starts with integrating societal need, I would caution ourselves from taking integration for granted. I would follow some earlier suggestion to problematize what is called integration imperative, the assumption that integration necessarily can and should be a regulative ideal. My own experience in creating meeting places or convergent points for researchers from different disciplines and from sometimes seemingly irreconcilable ways of knowing to come together suggests something a lot more scattered and without pattern. The HUC experience of My Climate Risk Lighthouse activity seems pointing to some alternative, innovative and experimental means of cross-boundary engagement with multiple, equally useful and meaningful forms of knowledge that in turn would enable desirable transformation of the climate of society, research scholarship, and the local communities itself. Back to you, Mandira.
Well, thank you very much, Sachi. Indeed, a very interesting presentation with us, having to think more about the indigenous knowledge and the way we need to really package our information to reach to the most vulnerable in terms of language or whether it is in terms of understanding. So thank you very much indeed. So now we've already heard from all our speakers for this particular session. We had a total of 5 presentations, 5 speakers. And I do see a lot of questions in the chat box and the question answer also box. And what I would like to suggest is that we now open the forum. We have roughly about 20 minutes for this discussion. Nico, can you please update us how much time we have for this discussion?
I will defer that to Helen.
I think we have about, I think we'll only have about 10 minutes, I'm afraid. So let's see how we go, Mandira. But let's get started, and I'll let you know when we need to wrap up and move to our Slido.
Well, okay, we have just 10 minutes. That's a bit too short there. But there has been a number of questions, and I'm sure, what I'm doing is here sharing the screen. Can you all see my screen here?
We can see that. Yep.
Okay, great. I just put in some of those questions that were appearing in the chat box as well as, in the question and answer box. So I guess as it appears, there seems to be a lot of interest on disasters, disaster risk reduction, as it impacts all our lives and livelihoods. So may I just read out this question? I think it's to you, Professor Dimri, regarding whether these disasters are really linked to rising aerosol concentrations. I'm sure there will be a lot of debate in this, but just a very quick answer on that, because I know, just some thought.
So briefly, I'll go one by one. Some of them I answered in the private to individual. Aerosol concentration, what presently we are facing, probably it's not those kind of hazard which I discussed in the Himalayan region. This aerosol concentration is primarily because of the emissions from the local, suppose in my room, we box it and then we keep adding on some pollution, and because of the stable conditions, and in North Himalaya is there, it is bringing katabatic wind down and atmosphere is stable, and that's where the aerosol concentration is increasing. Probably aerosol concentration in itself is a disaster from health point of view. And another question is primarily which features like duration and magnitude of the precipitation change more by climate change and monsoon. I think it's duration is also becoming a bit erratic. The point which I mean erratic in the sense there is a set duration where the more precipitation is likely to occur, as Professor Krishnan told in the beginning that Chennai still is getting rain. So time has also changed, and so is the magnitude also. Some of the part are getting more water. Local, in my understanding and research shows that local water body increases more amount of water circulation at the localized level, primarily in the Himalayan context. Yes, Professor Ajit Tyagi has talked of the human activities. Yes, human activities have a two-pronged approach in the Himalayan region. Humans are becoming minimal in the sense that they have a kind of a migration to the major cities as far as the Indian villages are concerned. And particularly when there is a kind of a disaster in the sense that there is a kind of a biodiversity shift is happening, the animals are coming down from their zones to the village, which are now vacated. And then primarily human disaster, if you want to look at that, more kind of tourism is increasing in the Himalayan region, more ecological imbalances are getting led because of the human interventions, roads, developments, if you want to say it like that, you want to see it like that. Communication system primarily is in the Himalayan region, which I know is based on the electronic sensors, which they have developed based on the mobile communication finally from one upper village to the lower elevation village and coming along the river floods. So in river plain, it's happening, and simultaneously to the previous question, most of the river flood plains are occupied by the humans, and hence the region which is supposed to be for the flood plain, it is for that. So this is very brief. Thank you very much, Professor Mandira.
Yeah, thank you, Dr. Dimri. One more question, just now, if you'll allow me as the chair. I was just wondering regarding predictions of floods and landslides, do we have such kind of detailed assessments done with the scenarios that we have in hand, or is that something that is yet to be done for the region?
As far as for the Himalaya in particular, the flood and landslide disaster are mostly linked with the precipitation forecast. In the last decades, precipitation forecast has increased a bit. Increase in that sense, I will not say quantitatively, but yes, qualitatively, the assessment is very accurate that the precipitation is likely to loom large, and these all disaster, in particular landslide and flooding, are linked to this large scale precipitation over the regional atmosphere over the Himalaya. But still there is more need to be done for a cloudburst leading to flash floods, landslides, and something like that. Yes.
Great, thank you so much, Professor Dimri. Okay, so I have some more questions here. I think I will, this is to Dr. Temia, I think, that is regarding your experience in terms of to include climate change into vulnerability over Pakistan. How do you include is what, and then, and what climate models are you using for this study? So I think part of it you've already answered, but what climate models are you using for the study is probably the question.
Yeah, actually, I have presented just a few assessment strategies that could be used to assess the vulnerability. But we have started a new study in which we are using agriculture pathway RAPs and RAP analysis, agriculture representative pathways, in order to assess the vulnerability and climate change impacts on agriculture production and agriculture, even agriculture natural resources to some extent, because in this methodology we use stakeholders and we ask them, we present different scenarios, we ask them very questions, including all these stakeholders. We assess what is the existing vulnerability and what will be the future vulnerability. So it is at the initial stage, that's why I haven't presented, but we are using RAPs for assessing the vulnerability. Thank you.
Great, thank you very much. And I think there's this other question here, the second one also, in terms of, whether you are looking at the anthropogenic forcing agriculture as well.
Yes, we at the moment we are not looking at that, but this is very important. It can be looked at because human activities are affecting affecting different emissions of greenhouse gases and even increasing climate change impact. So that could be looked at. Yeah, I agree with the Sanaz. I think she has given this question, raised this question.
Mandira,
Yes.
let me just interrupt quickly. Just one more minute for questions,
sure.
and then, okay.
Thank you. Yeah, I was just about to done anyway. So thank you very much. Yes, Temina, for your nice responses. I think the last question that we see here about the ensemble models would also apply to the next session here when we're talking about climate science. So I think we can hold this one to be better answered also by the next session, if you'll allow me. And so with that, I'd like to thank I think all the speakers here for their excellent presentations. I think much has been said about the user perspective, and some of the key points that I was hearing, some of the key, I guess, words, I must say, that I was hearing was like co-development. I think co-development with the users is extremely important, particularly when you are trying to integrate the societal aspects into the use of the climate science that we have. Otherwise, if you just, bring it out without their involving them right from the beginning, it is difficult. And another aspect that I was also hearing was the need to also look into the knowledge of the users. For instance, the indigenous knowledge that exists in the users, their experiences, like Professor Subimal mentioned about the farmers' experiences in terms of scheduling of irrigation, for instance. Yeah, so those kind of experience or other experiences that the users have, various users have, that could be also better integrated with the current science knowledge that we have, and look at it in terms of the user perspective and see how that can then reach to the last mile benefit. Another is, of course, the tailoring of the climate services, and that also very much, gels with what we are saying in terms of the co-development and also the co-design of the systems. The vulnerability assessments, so use of the various tools that are there. It is also important, in terms of applications, in terms of looking at the impacts, it's important to look at the vulnerability assessments also. We also heard about the word impact-based, forecasts, for instance, and that is gaining much more attention these days. It's not only about talking about what the weather will do, but what the weather will be, but what the weather will do. So it's more at that level, and what the impacts will be if you're looking at more in the long term in terms of the changes that we are seeing in the climate. So impact-based forecast would then be extremely important for us to really look towards, and then working with the users in terms of a participatory process is also important. That would very much relate to the co-development and the co-design, co-production of some of these information that we need. And I think with that, I think I just would like to stress that there is a need to co-design, co-produce the climate information that we are generating. And this would adhere to very much with the, the suggestions or the guidance of the global framework for climate services that we also try to implement in terms of reaching the last mile. And then also, as was also mentioned by Helen, I think education is also critical, and also raising the awareness as well as the building of the capacity at various levels is also essential. So it would be at the user level, there could be various levels of users that for whose capacity needs to be built. So therefore we need to really take that into consideration and ensure that the products that we are developing is really informing decision-making at the various levels that needs to be done, particularly to enhance and build climate resilience. So I think with that, I would like to thank once again, all the speakers as well as the participants here for their excellent interaction and questions. So thank you very much again for that.
And thank you, Mandira, for a wonderful summing up there of the session. I thought that was really nice, and I totally agree with many of your points. So that was a really nice reflection on all that we heard. And I also want to thank all the speakers. It was a really rich session of information. I know we went a little over time and we didn't have enough time for discussions. That always happens. But Mandira, I think you summed it up really nicely. If I can ask you to just stop sharing your screen, I'm going to, so you have. I'm now going to share mine back before we go to the next session, because we're going to, if I can make my computer talk to me, it's just asleep a little bit. Here we go. We just want to do the first of the Slido surveys. And so head over to Slido now, and we've got a series of questions. Firstly, just we're interested to know a bit more about you, whether you're a researcher, scientist. You could be also a user of climate science data, or you might work in a consultancy company or an engineering company or a government department, and you might be a user of climate information. At the moment, it looks like our audience of 166 people are mostly researchers and scientists. So that's good to know, and you'll really enjoy the next session. So I won't keep us too long from that, but oh, that's good. We've got some people here who are users as well. And that's important for some of these points that Mandira summarised and each of our speakers spoke to. So the next question actually is a little bit similar, but it goes into slightly more detail. So I'll just let people enter their numbers. So this one is, we're keen to know which sector you're from. And that's good to see that we've got an interesting spread. Many of you from national government, but we've got almost half other as well, which is interesting, and a non-government as well as some humanitarian aid agencies. So it's a good cross-section of sectors represented and listening today, actually. So you'll all be have different needs, I suppose, from some of that information that we saw presented. And you know, if I think about the different sectors that you're from, that point that Mandira made about the importance of co-design, you know, we can't imagine that we're going to deliver climate information that meets your needs without sitting down and talking to you about what those needs are. And, you know, because each of these different sectors has different needs. So that's really interesting. So I'll just keep going. So you've already, some of you have started on this. We're also keen to know about whether we're hitting the target, as it were, in terms of our goals around climate information needs. We always like to see scores in the 4 to 5, but we welcome the feedback at the other end as well about what we could be improving on. So this poll will stay open, so it's okay if you're still answering one of the first questions. I'm just going to step us through the questions. So that looks like it's pretty much stabilized. Now, Shashi spoke to the My Climate Risk Lighthouse. I put the comment in the chat. Ted Shepherd, who she spoke of in her presentation, is one of the co-leads for My Climate Risk, and you will have got a sense from her that it's taking a different approach actually, and it's quite innovative and interesting. So we're keen to hear from you whether you think, I know you probably haven't heard very much yet, but even just based on what you have heard, whether you think that that is going to address some of the needs that you've got. So thank you for that. And Hindamathy, do tell me, I think, yes, this one is part of the session, isn't it? This is about climate information gaps. This is an open text question. So you've already started to populate that. That's great. So we will now go to the next session, but we'll keep the survey open till the end, the Slido open to the end of the next session. So you can keep populating it as we listen to the next session. But I must now, because we're a little bit behind time, we're not too bad though, I'm going to now hand over to our chair of our next session, Mohammed Amjad. Thank you, Mohammed, for being our chair of this next session. And we have a series of talks now, really, even though we have actually had a fairly comprehensive look at some key science challenges, but we'll keep now talking about the science and particularly some of the real priorities and issues for the region. So without any further delay, I will hand over to the chair, Mohammed. I will stop sharing and you can introduce the session. Thank you.
Yeah, thank you very much, Helen. It was really useful to listen to you before the session and our Slido part as well. So participants, now we are in session 4 of our WCRP research forum. We just heard from the previous session that was on the societal needs, and to fulfill those societal needs, we know that we have some scientific challenges as well. So to discuss those challenges, we have this session in this forum, and I'm going to introduce our first presenter, Dr. Krishnan. Dr. Krishnan is acting director at IITM and executive director at the Center for Climate Change Research at IITM India. So please, Dr. Krishnan, the floor is for you. Please share your screen and start.
Thank you, Chair. So is my slide visible? Hello?
Yes, go ahead, Krishna.
Yes. Yeah, so we have heard from the previous speakers that the extreme weather and climate events are happening everywhere and also South Asia. To make reliable attributions, robust attributions and reliable projections of regional climate changes at regional scales, it is a scientifically challenging issue. So we need to, first of all, advance our scientific understanding and the foundational scientific basis for the regional climate extremes. So in this presentation, I will briefly cover what are the key regional climate science priorities, what are the opportunities and challenges for the South Asian region. This is a contextual setting of the regional Earth system for the South Asian regional climate system, Earth system. Basically, this region, we have a unique land-ocean geographical features, the high elevation features like the Himalayas, the Tibetan Plateau, Western Ghats, the Burmese mountains, and the adjoining Indian Ocean, Arabian Sea, and Bay of Bengal. It's a very, very unique setting, geographical setting. It has the strongest regional monsoon in the world. So the mean climate in this region is dominated by a very strong seasonal cycle. You can see that in the temperatures, in the winds, in the precipitation. And basically, the regional climate system is coupled, the atmosphere, the ocean, the land, and the cryosphere. They're all very strongly coupled. And the internal dynamics in the system is very, very strong because of the interactions in different space and time scales. And also this region is influenced, the climatic variations, weather and climate in this region are influenced by teleconnections, by remote drivers like the El Nino Southern Oscillation, Indian Ocean Dipole, and several others. And there are natural forcings, elements like the volcanic eruptions, solar irradiance changes that are also affecting both the global and the regional climate. And then you have the anthropogenic external forcings like the greenhouse gases, aerosols, land use, land cover changes. So this is just to give a context, regional context. And coming to as I said, the Himalayas, the Hindu Kush Himalayan region, this is a very, very important region. It is the driver of the strongest monsoons on the globe. It is the source of 10 major Asian river systems. It is the largest reserve of ice outside the polar region. It's a biodiversity hotspot and a diversity in culture, traditions, and languages. And interestingly, we see in this region, the Himalayan region, the temperatures have increased by about 1.3 degrees since 1951. And and this is much higher than the global mean temperatures. In comparison, the temperature over India has risen at a much faster rate, much slower rate. The adjoining Indian Ocean, tropical Indian Ocean, has also warmed by about 1 degree since 1951 to 2015. And more importantly, the high elevations in the Hindu Kush Himalaya, especially the Tibetan Plateau, have experienced stronger warming, something like 0.3 to 0.5 degrees per decade. This is known as the elevation dependent warming. And the snowfall has declined in this region, the Hindu Kush Himalaya, and several glaciers have retreated, with the exception of maybe the Karakoram in the Western Himalaya, where this region has experienced slightly higher winter rainfall, which has shielded the region from glacier shrinkage. So this is a brief background, and many of these regional changes in the regional features, for example, the changes with temperature and precipitation changes over India, the sea surface temperature of the Northern Indian Ocean, the sea level rise in the Northern Indian Ocean, and the snow cover extent in the Himalayas, what happened in the past and what are the future changes and their attribution. This has been covered in our recent assessment of climate change for the Indian region. This is from the Ministry of Earth Sciences from the Indian government. And so what are the key regional climate science priorities? I have just listed a few, just 4 of them that come to my mind. One is the weather and climate extremes, the monsoon rains, which are becoming unpredictable. And the third one is the Indian Ocean sea level rise. And the fourth one is the Himalayan cryosphere. And this is a quick summary of the weather and climate extremes. In this region, we have seen several heavy precipitation events that have led to floods. And some of them are related to interaction between the monsoon. This has happened during the summer monsoon season, interaction between the monsoon synoptic systems and the extratropical circulation. The examples are this big flood in heavy precipitation, extreme precipitation in Uttarakhand in June 2013. It was the interaction of the strong monsoon circulation, very strong anticyclone in the upper troposphere. And the monsoon advanced very early, and there was an interaction with the deep trough intruding right from the polar region, from the extratropics. And this led in the middle and upper troposphere, even in the lower troposphere, this led to strong convergence and heavy precipitation over this region. And this is the scale of flooding, and this is over in the Rishikesh region, where this giant Shiva statue was all affected very badly. And a similar situation in Pakistan in 2010 due to an interaction with the extratropical circulation happened. This resulted in major flooding in Pakistan. And so typically, and we know that other extreme events in this region are linked to changes in the jet stream, both the subtropical and the mid-latitude jet stream. And several studies have attributed this to the rapid Arctic warming. So if the Arctic has been warming and the ice is melting very fast, so there can be more absorption of heat, and this region, the temperatures can increase. And due to these changes in the temperature, the atmospheric flow pattern, especially the jet streams, can weaken, and there can be large meanders, and these meanders can cause extreme weather. So you can have global drivers, but major regional impacts. Also, 2010, we saw major floods in Leh. This is one of the cold desert-like region in the Ladakh region, high elevation Himalayas. This was due to development of mesoscale convective systems that happened during August, immediately a week after the Pakistan floods. And so there was moisture inflow from the Bay of Bengal. And so these mesoscale convective systems, they triggered heavy rainfall and flooding. And extreme precipitation events have also occurred due to El Nino events. And we know that with El Nino, with future warming, it is projected that extreme El Nino events are going to become more common in the future. And this is by a paper by Venju Chai. And we had one such extreme El Nino in 2015, which led to a major drought in India. In fact, we had 2 consecutive droughts over India, one on 2014 and another one in 2015. So due to the strong decrease of monsoon precipitation due to the extreme El Nino, the soil moisture became very dry. And this led to heat extremes in 2016. And interestingly, in the winter time, in the northeast monsoon time during 2015, Chennai received, this is in peninsular India, the northeast monsoon was very strong. It led to heavy precipitation and flooding. And so floods are also increasing, partly due to the heavy rainfall and also due to changes in the land use, land cover due to human activities. And right now, as I speak, we are witnessing heavy rainfall during the northeast monsoon. It's very, very active in peninsular India, and heavy rains due to synoptic low pressure systems forming in the bay and moving inside into peninsular India. But this has been very, very persistent. Also, the other modes of variability, like the Indian Ocean dipole, which was very strong, extreme IOD during 2019, it led to heavy rainfall and flooding in several states in India, and also Kerala, which was heavily flooded in 2019 in August. Just a week of rainfall led to this heavy flooding. And in fact, 2018 August was a heavy precipitation and flooding. So this is becoming very, very common, these extreme events.
Krishnan, you have 3 minutes, please.
And lastly, this monsoon precipitation, hydrological changes, we are also able to attribute how human influence has altered. We understand that greenhouse gases are trying to strengthen the monsoon, whereas the aerosols have kind of contracted, especially the northern hemispheric aerosols. And we do see the signatures of this in the observed precipitation changes. But the one thing is there is a lot of considerable intermodal spread, which we need to address. That's one of the uncertainties. And in the future, we know that with increasing global warming, monsoon is projected to increase. But in the near term, there is considerable internal variability of the system, which reduces our confidence. The other component is Indian Ocean sea level rise due to the due to warming of the Indian Ocean and thermal expansion. Indian Ocean sea level rises, sea levels have risen, but there is substantial decadal variability, which can be modulated by other drivers like the El Nino Southern Oscillation, also in strength of the monsoon circulation. So decadal changes in the monsoon circulation can also affect the heat transport in the ocean and also modulate the sea level changes. So this is one of the important drivers. And the other point is now, as extreme tropical cyclones are becoming more extreme in the region, they can also influence the coastal sea level changes. That's an important point. And for example, we have seen especially the Arabian Sea is becoming very, very active. Recently, we had the Taukte tropical cyclone in May 21. And the models are able to do a reasonably good job, the NWP models. But what about its coastal impacts of these cyclones? And there were also other cyclones like the Nargis in 2008 and the Gonu in 2007, which went towards the Oman coast. So these events are becoming more and more common. So their impact on sea level becomes very, very important. So this is my last slide. So the science priorities and implementation. So we have 4 main science priorities, one on the weather and climate extremes, the other one on the monsoon hydrological cycle, the third one on the Indian Ocean warming and sea level rise, fourth one on the Himalayan cryosphere. And they are all closely connected. So basically, we need an integrated strategy to address these science priorities. So, and these all these science questions, they are all linked to the core projects of the WCRP, the JUVEX and the Cleugh, as I mentioned in my slides, and also to the Cleugh, Spark, and because of the atmospheric dynamics and the WCRP Cordex. And and they have strong links to the lighthouse activities, which Helen explained in the beginning. So to address these in an integrated way, they are linked to the explaining and predicting the Earth system change. You need the observations, the models, also the data assimilation system, early warning system to predict these extreme weather and climate extremes, and also the monsoonal changes. And you also need the digital Earth to have a digital representation of the regional processes in the past, in the present, and the future. And we also have the regional climate risk. My climate risk also is an important, because if you want to deliver reliable regional climate information, assessing the risk becomes very, very important. So these have strong linkages. In addition, the WCRP Academy, building the human capacity in the region by training and education becomes very, very important. So to address these in integrated strategy, you need process understanding and improved representation of these processes in models, and also advancing predictions. So with this, I come to the end of my talk. Thanks very much for your kind attention.
Yeah, thank you so much, Dr. Krishnan. I think you have covered almost everything, and that's very nice. Except the challenge of winter, like we call, where we have a cold mass trap our whole Indian region, and which causes a lot of pollution in our cities. So now I'll go to our next presenter. He's Dr. Our next presenter is Professor Tarotturao from Kagawa University, Japan. He's from the Asia Precipitation Experiment. So please, the floor is for you, Dr. Tarao. Please share your screen.
Thank you very much. Thank you very much. So I come from Japan, and so we are now launching another new project named ASIAPEX. So it is the abbreviation of ASEAN Precipitation Experiment. So we are focusing on the ASEAN precipitation system in the 4 ASEAN regions. And so I'd like to introduce some aspect of our projects, and I'd like to discuss with you more about this. Thank you for inviting this very interesting and very nice forum for the climate research. So I'm very much happy to be here. Thank you very much again. And this is our title, but it is our project is in the WCRP framework, as you know. And so I'd like to show you some slides about that. And I like to share this. And this is some different slide, but this one. So so we are now in the one panel in JUX. JUX has 4 panels, and one is the GHP. This is very near to the ground level, and so it is very much related with atmosphere land interaction. And the water cycle is very important there, because the water evaporation and the transpiration and the rainfall all occurring on the boundary of the Earth surface. So we are very much focusing on this area and making our research plan. And also the monsoon very important for our ASEAN region. So the monsoon panel in WCRP is also very important partner for our research project. And now JUX has many different RHPs in different areas in the world. And ASIAPEX is very much related with the ASEAN area, maybe some broader areas, including Japan or northeastern part of ASEAN area, and also in South Asia also very much important part, and the Indonesian region also included, and some specific area also included. So our area is very wide like that. And we are now conducting new projects from 2019, and before that we had other 2 hydroclimate projects in ASEAN region, named again and Mahashuri. So we are intending to be a successor of the 2 very important and epoch-making projects. And so we are now taking over these activities and extending new activities. And I'd like to back to the original slide, and just wait. And we would like to show some activities of our ASIAPEX. And this is some introduction about the JUX and the mechanism of the GHP and our place where we are in the WCRP framework. And the objective is like this. We are now facing a very rapid global warming, and so that's changing. Many things are changing, but our topics, basically very scientific topics, are very focus of our research activity. And in the ASEAN region, the land surface is very important, and the precipitation is very important aspect of the ASEAN monsoon. And so we like to focus on the ASEAN terrestrial precipitation, and it's very much related with diverse hydroclimatological conditions on the ground. And this is very complicated, very interacting system. So very difficult to predict and difficult to catch the mechanism. So the most very difficult part of that our science may be very near to the surface, very difficult to observe and difficult to catch from that satellite, and very difficult to reproduce in the models. So we like to focus on this very basic but very difficult things, and how that our ASEAN hydroclimatological system will change in the near future under the global climate is very highly depend on this knowledge. So we like to focus on this topic, and for some practical use also. So it is very important for the prediction of the disasters. And disaster reduction very important, and also we have to look for the future to make sustainable development of our society. So we focus on these topics. It's very big and very difficult to tackle, but our focus is maybe in the science on the very difficult systems in the ASEAN terrestrial rainfall precipitation, including solid phase precipitation also. And we are now the status of GeoX Prospect RHP. And we are now launching project and now making our science plan. And after that, we are now intend to be an initial phase of RHP of the GeoX perspective. And we are taking a kind of the approach-oriented strategy like this. And not regional, but the strategy as an approach-based strategy is our way to go anyway. And six approaches have been identified for our research project. There's different aspects are there. First one is observation and estimation of the precipitation itself. Is very important, but very difficult to find. And for example, that the high mountain area is very important area for the water resources for very wide area of the ASEAN areas. But that the estimation of the rainfall in the high mountain area is very much difficult to know, or it has very big ambiguity anyway. So in some estimate and in other estimate, the results very different sometimes, and it is very much important for the evaluation of the future change in the glaciers in some areas. But that the estimation of the precipitation is very difficult, and we have a TRIM satellite, but the ice phase is very difficult to catch for this very nice satellite. So now we are going to the next phase of the satellite to GHP, and we are now developing new way to detect the accurate rainfall or precipitation in the high mountain area. But for that, we need the ground truth anyway. So we have to run some real observation in the high mountain area also. So we include some project about that also. I'll show you later. The second one is a process study of land use land cover change. It's very important, and it coupled with the convection above that ground, and this is very highly interacting and non-linear phenomena to catch. It's very difficult to catch. So we want to be focused on this topic, and this is our second approach. And third one is the predictability of sub-seasonal to seasonal scale. And it includes that interaction with the system in Pacific Ocean or some other surrounding areas of Asia climate. And sometimes some impact from the ENSO is very important. Sometimes the IOD is very important. Sometimes there's a memory of land surface. Soil moisture is very important for that this sub-seasonal to seasonal scale variability of the climate. So we like to be adhere to this point to make up our approach. The fourth one is high resolution hydrological modeling, including the anthropogenic and the glacier impact to that. And human also make very big impact on the hydrological system in the land area over the Asia. But that uncertainty in this point is very large and very difficult to know. But it is very important in that side. And also glacier is very important for that our system, the hydrological system in the Asiatic regions. So these two factors, anthropogenic and glacier factors to the hydrological model have to be very important factor for our research. Fifth approach is related with our observational activity combined with the modeling initiatives. And we have maybe 10-year span. So we like to make some integrated cooperating observation campaign in the highly worldwide activities. And using that with the modeling initiatives, we like to see that how these observation have impact on the predictability of climate system, including ASEAN areas. And sixth one is our mission maybe. And so because of that climate change, which is rapidly going on, so we like to, we should show some concrete results to the public from our knowledge. And these future projections have to be effective and also have to be reliable. How to make reliable future projections, very important topic for our research. For that,
Professor Feba, you have 3 minutes, please.
Okay, thank you very much. For that, we need to get that good insight into the scientific view of Asia monsoon system itself. So our we are so much interested in science itself. And we are now going through these 6 approaches. It may combine many different areas of the world, in Asia also. And so we like to take this type of regional approach-oriented research, but it connects many different regions. So this way, we like to go to proceed our research activity. And we have already conducted this kickoff conference in 2019. And we had a very nice discussion there to confirm our approaches are very attractive to the people related with the hydrochronological systems. And we are now discussing about the review paper, and now almost submitting phase. So I hope we can show you some new review paper to you in public. So publication, I expect like that. And we have many activities in the conferences, and also we have some activities in South Asia also. And this is also very important area in our region. The one is the workshop in 2020. We had a workshop on the Asia-Pac South Asia in the Central University of Rajasthan in the southwest, northwestern part of India. Or Central West. So anyway, we had very nice discussions there, and we enjoyed so much. And so we'd like to collaborate with you on this in this research plan. And I expect many of you will participate in our research activity. And also summer, South Asian Meteorological Association invited me for a speaker, so we have good experience in this workshop. And we are now doing many research activities, and many initial outcomes are very interesting, very high resolution precipitation climatology data set from satellite, and also how that the land surface acting on that the mesoscale convective systems formation. And for that, inhomogeneity of the land surface plays very important role for that the formation of the mesoscale convective systems. So this way, that the land surface and atmosphere interaction is very important. So we have many other activities like the very big, large-scale climate predictions included. So anyway, I expect your participation to our research project and work on the collaboration also in near future. So I may wrap up here. Thank you very much. That's all.
Thank you so much, Professor Rao. It was really useful, and I'm sure that the product will be highly beneficial for the region. And the information from all integrated kind of resources will be very useful for the regional information on precipitation. Thank you very much for your presentation.
Thank you very much.
Ladies and gentlemen, now we move ahead to our new presenter, Dr. Zhao Wang. She's from University of Illinois, US, and Dr. Wang is co-chair of the WCRP working group on tropical meteorology research, and she also co-chair on working group 3 under the WCRP lighthouse activities. So over to you, Dr. Wang.
Thank you, Chair, for the introduction. First, I want to acknowledge the two co-chairs of the Lighthouse activity, Dr. Rowan Sutton and Dr. Christine Fendel. Many slides in my presentation are provided by them. Okay. This slide, sorry. This slide shows the overarching objective of the Lighthouse activity. It is to design and take major steps toward the delivery of an integrated capability for quantitative observation, explanation, early warning, and prediction of Earth system change on the global and regional scales and multi-annual and decadal timescales. Some examples include the hiatus changes in the IPO, interdecadal Pacific oscillation phase, changes in the A-mark oscillation circulation, and also changes in ocean atmospheric circulation and their influence on hazards. The latter one is a key issue for adaptation. As Helen mentioned earlier, there are 3 themes. The first theme is monitoring and modeling Earth system change. The second one is integrated attribution, prediction, projection, and early warning. The third one is about the assessment of current and future hazards. We have 3 working groups focusing on the 3 themes here. The Lighthouse activity will take a cross-cutting approach, including like integrated use of observations and models to characterize and quantify uncertainties, which are fundamental to attribution studies. We hope to answer the question, to what extent models and observing systems are adequate to explain and predict Earth system changes. We will select case studies of significant changes and multi-annual and decadal events. We hope to promote and coordinate targeted research to quantify, explain, and assess the predictability of such events. Also, the case studies, we hope the case studies will integrate insights from all the three themes. We recognize large ensembles as an important approach to address these questions. In particular, large ensemble single force experiments are necessary for quantitative explanation of Earth system change. And also high resolution ensembles are necessary to understand the regional circulation changes and modulations of hazards. But when it comes to like high resolution ensembles, we also need to deal with an important question: the balance between large ensemble size and high model resolution. This effort is in collaboration with the Digital Earth Lighthouse activity. For the shorter term, we have the following priorities or action items, including attribution of causal forcing factors, event evolution, and early indicators of case study onset. We want to address the question: can the current observing system capture early indicators and monitor event evolution? If not, what recommendations can be made for system improvements? For using case studies, we hope to assess the hazard risk and also whether models can simulate the full evolution of case study events, what model biases exist, how such biases affect the representation, simulation, projection, and prediction of such case study events or hazards, what methods can be taken to reduce such biases, especially through process-oriented diagnostics and model calibration. For the longer term, over 5 years, we aim to have established methodologies for novel case study application, an international open access multi-model archive of seasonal to decadal handcast and forecast dataset, improved capabilities for prediction of multi-annual to decadal changes in climate system and their impacts on hazards, and also quantitative assessments of the current risk of specific hazards and future risk under defined scenarios.
So you have 2 minutes, please.
Okay, this is my last slide. When it comes to Southern Asia, there are some specific hazards, as mentioned in a previous slide by Krishna, including extreme precipitation related hazards, persistent droughts, heat waves, tropical cyclones, storm surges. Such hazards often produce headline stories, but there is virtually no information about attribution and explanation of multi-annual to decadal changes in Earth system. We believe it is important to address the following questions: how are hazard distribution and the other properties modulated by natural variability on the interannual to decadal timescales, and how predictable are these modulations? How has climate change affected the distribution and other properties of specific hazards? And what further changes should we anticipate? To what extent are models and observing systems adequate to address these questions? And also, what are the required minimum ensemble size and model resolution to address these questions? Okay, that's it. Thank you.
Thank you so much, Dr. Wang. I think your presentation is very interesting, basically on the aspect of attribution side of this, some extreme events over South Asia region. And now we are proceeding to our next presenter, Dr. Sanjay. Dr. Sanjay is Senior Scientist in Indian Institute for Tropical Meteorology in Pune, India. So before giving the floor to Dr. Sanjay, I would like to request the audience to please send your questions in Q&A window, and also request our panelists to please have a look on questions, so that in question session we will be delivering those answers as well. So over to Dr. Sanjay.
Thank you, Chair. Am I audible?
Yes.
Yeah, and the slides are visible, right? The slides are in full screen.
Yeah, it's perfectly fine.
Thank you. Thank you very much to the organizers for giving me this opportunity to showcase this brief on the Codex South Asia high resolution projections. The Codex activity, as has been told by Dr. Helen and Dr. Krishnan, is the regional activity of the WCRP with the aim to advance and coordinate the science and application of regional climate downscaling through global partnerships. So currently there are around 14 continental regions covered by the Codex activity, and we, the Center for Climate Change Research in the Indian Institute of Tropical Meteorology in Pune in India, is coordinating the activity over the South Asia region. And there are a few high resolution 50-kilometer dynamically downscaled CME5 projections available for Codex, which have been used widely. There are currently around 26 projections from the RCP projections from the CME5 global model subset, which you can see the details on the Codex website. The contributors are from IITM, from SMHI Sweden, and more recently from JERIX in Germany, and the CLM community have contributed to the core activity, where yet higher resolution of 25-kilometer simulations have been made available. A subset of this is now available on the Copernicus climate data store, which have been used as a contribution to the IPCC Assessment Report 6 Working Group 1 activities. And the main highlights of the Codex currently are that the Codex Science Advisory Team has developed an experimental design for dynamic. As the users are welcome to comment on the variables which they would like to see from the Codex output. So please see the Codex website. Your groups can contribute to the simulations, also can be interacted with the point of contacts for the South Asia region. The Science Advisory Team has also developed a white paper with the purpose of to point out the scientific challenges in the regional climate modeling, and which is also sets a basis for the future Codex Science Plan. They have also established a set of flagship pilot studies with the aim of improving the capability of models in reproducing the regional climate features with a focus on extreme events, in one of which we are also from India involved in the Tibetan Plateau region. I'll come to that later. And this high resolution ensemble of Codex downscale projections provided the opportunity for all that we did mention in the beginning, and they looked at different aspects like the precipitation extremes over India, the climate uncertainty over the Himalayan water towers, and added value, whether there is added value of downscaling and all that. So it has not only produced opportunity, it has also produced new challenges on how improving the downscaling techniques. So these all you can see on the Codex web page. And more recently, there has been a study from the ICTP looking at the severe potential for thunderstorms to happen in the future. This was the study used the Codex core 25-kilometer simulations from the REDCM model. So these kind of studies looking at the societal impacts also are coming up with the Codex projections. The Codex projections have also been used for assessments of regional climate change over the Hindu Kush Himalaya region, which was coordinated by the ICIMOD Kathmandu in Nepal. Dr. Mandira Shrestha and Dr. Arun Shrestha played a big role in this. And also, as Dr. Krishnan mentioned, the assessment of climate change over Indian region for the Ministry of Earth Sciences, Government of India also had a nice contribution from this Codex high resolution downscale projections have contributed to this activity too. We also do the training activity. Yeah, I'll be finishing now. The training activity in from 2012, and more recently, the ICIMOD has been doing during the pandemic. Also, the online training programs have been done under the UK-funded ARC activity, and more trainings are coming, as Dr. Mandira Shrestha just have shared in the chat. The IPCC report used for the first time used the Codex projections together with the global projections CMIP5 and CMIP6 in assessing the uncertainty of the climate impact drivers. You can see the assessment report, and these projections are available on the novel IPCC Working Group 1 Interactive Atlas also. So that way the Codex is visible now more. Finally, the IITM is involved as a modeling partner in the high resolution climate modeling over the third pole region, the Tibetan Plateau and the adjoining regions, with a focus on convection permitting simulations. This project is led by Professor Deling Chang from Sweden, and please see the project website for. It's still open for research teams to join for analysis as well as contributing the model studies. The working group on modeling is led by Dr. Andres Perin, who has presented recently the first initial result of the intercomparison with the different models for a case study of mesoscale convective system. And the results show that actually the performance between modeling systems differ each other, and the large observational uncertainties complicate the evaluation of convective permitting models in the Tibetan Plateau region. That's all from me. Thank you very much once again to the organizers, and please contact the point of contact for the Codex South Asia for more details. Myself, Dr. Mandira Shrestha, for dynamical downscaling, and Dr. Professor Lalu Das and Dr. Koji for the statistical downscaling activities. Thank you very much.
Thank you very much, Dr. Sanjay. It's really nice to listen from you. And now we are going to our last presentation of this session. And last but not least, we have Dr. Roxy Cole and Ms. Aditi Modi from the Indian Institute for Tropical Meteorology. So over to you, Dr. Roxy Cole.
Thanks to all the participants for listening to the WCRP discussions on the climate research priorities for the next decade. I am Roxy Cole from the Indian Institute of Tropical Meteorology. I'm also a co-chair of the Indian Ocean Region panel and associated with the International Indian Ocean Expedition. With me, I have Aditi Modi, who is also an early career researcher from IITM and who is associated with the IOE too. And most of the extreme weather event and climatic changes that we have seen in some of the earlier presentations and some of the earlier slides are related to changes in the Indian Ocean, drastic and rapid changes in the Indian Ocean. So here I am looking at the observing system, the Indian Ocean observing system that we need for addressing these challenges and priorities for the next decade. And here you have the take-home message. I have the take-home message in the first slide itself, and we will go through this one by one. The Indian Ocean is warming at a rapid pace. You can see the temperature changes during the last several decades. It's going up to 1.2 degrees Celsius, which is much larger than the temperature changes that we have seen over the Indian subcontinent or even the global mean temperatures. And this is presenting new weather and climate challenges to South Asia, which requires us to redesign the observing systems in the Indian Ocean that are required to address these challenges. And these kind of redesigned observing systems and forecasts using them require regional partnerships and data sharing. Now, coming to, let me change the slide over here. Yeah, coming to the Indian Ocean, I told you that the Indian Ocean is warming at a rapid pace. And this is one of the most salient points that the recent 6th assessment report from IPCC has pointed out. So this from one of the chapters. I have highlighted this point. Since the 1950s, the fastest surface warming has occurred in the Indian Ocean. And this is compared to all other ocean basins. Now, this is about the observed warming, which you have here from about 1870s to the recent period, 2020s. But if you look at the projections dwarf the warming that we have seen so far. The projected warming is at about 0.38 degrees Celsius per decade, or 3.8 degrees Celsius per century, which is much larger compared to the 0.12 degrees Celsius that we have seen so far. So the impact of the observed changes are large. We can't even imagine the impacts and the challenges we might face with the projected changes in Indian Ocean warming. Now, let us look at some of the impacts that we have already seen over South Asia and the adjoining regions of Indian Ocean due to this observed Indian Ocean warming. One of the largest impacts are obviously on the monsoons. We have the South Asian monsoon or the Indian monsoon over this region. There are floods and droughts in response to the changes in the monsoon. And similarly, there is a response in the African monsoon as well, Southeast monsoon, and also the Australian monsoon. So mostly one of the largest changes, there are increased activity in terms of floods. And occasionally in some regions, we have droughts and wildfires and even locust swarms because of increased convection in the Western Indian Ocean region. So this is one kind of response in the monsoon. This is also evident in the subseasonal variability of the monsoon also, which we call the MJO, Madden-Julian oscillation in the winter, and the monsoon intraseasonal oscillation in the summer. So there are evident changes in these intraseasonal variability as well. And then, like Dr. Krishnan and others mentioned, there are changes in the cyclonic activity as well. For South Asia, the cyclonic activity in the North Indian Ocean, the Bay of Bengal and the Arabian Sea are the most important. And we are seeing statistically significant change in the frequency, intensity, and duration of cyclones in the Arabian Sea particularly, and associated storm surges as well. Now, another factor is terrestrial heat waves, especially over the northwestern Indo-Pak region and adjoining regions during early summer or the pre-monsoon period. And similarly, similar to heat waves over the land, we have heat waves over the ocean as well. These are called marine heat waves. These are high temperature events in the ocean, which are above the 90th percentile and can lead to coral bleaching and are detrimental to the marine ecosystem. So these kind of marine heat waves are increasing. And another impact of Indian Ocean warming, particularly the warming of the surface ocean, is that it prevents the mixing of subsurface nutrients to the surface for the phytoplankton production. And this is because of a process or a situation called stratification, surface stratification, because the surface waters are less dense and warmer. And this leads to a declining marine phytoplankton in the Western Indian Ocean and the Arabian Sea region. So this is a largely productive, biologically productive region. If you look at the food chain, the most biologically productive area of the region is the Western Indian Ocean region because of the upwelling winds during the monsoon. But the marine phytoplankton production is declining, which could cascade and impact the marine ecosystem and the marine fisheries as well. And sea level rise has been already talked about. It's an important factor affecting all these regions, particularly Northern Bay of Bengal, Bangladesh, those regions where the land subsidence is also larger. And observing these all challenges, or understanding and monitoring and forecasting these challenges, require high density observations. And that is a challenge that we have to deal with in the coming decade. And all these changes, the changes due to Indian Ocean warming are not confined to the Indian Ocean Rim region or South Asia. They affect the Pacific, the Atlantic, and other extratropical regions as well. Now, I'm not going to each of these events one by one, but I will show one or two of some of the extreme events originating from the Indian Ocean. And one of the most particular event is cyclones, tropical cyclones, because cyclones, extreme rainfall events, all of these events draw their moisture, source of energy, the moisture and the heat from the oceans. And Indian Ocean is the warmest, and it's also at the warming at the fastest rate. Now, if you compare the cyclones for the other regions, the Indian Ocean, the North Indian Ocean comprises only of about 6% of global cyclones. But the fatalities are quite large, global fatalities. Now, cyclone forecast skills have improved tremendously, but the damage is still high as the frequency, intensity, and duration of cyclones have increased. And why? One of the reasons is that the rapid intensification of cyclones are happening because of warmer Indian Ocean waters. Cyclones are intensifying. One of the examples is Cyclone Amphan in the recent period. It intensified from a Category 1 cyclone, which is about 100 plus kilometer per hour speed, to a Category 5 cyclone, which is about 200 to 250 kilometer per hour speed of cyclone in less than 18 hours. Now that gives us less time to respond on ground. Also, it is a challenge for forecasters. We have seen that extremely high temperatures, which are characteristics of a marine heat wave, have supercharged these cyclones. Now, this is a normal temperature conditions, which is around 28 to 30 degrees Celsius. But just prior to cyclones, we are seeing marine heat waves straddling around 31, 32, or even 33 degrees Celsius. Now, that requires, to understand and predict these events, requires subsurface data also. We need improved wind coverage to monitor these cyclones.
Okay, you have 3 minutes, please.
Marine heat waves. Now, the same marine heat waves that affect the cyclones also lead to incessant coral bleaching out as well, that you see here. Corals have mucous membrane known as the zooxanthellae, which acts as their shield and gives a color. Warm temperatures bleach it away. So we need to start monitoring these marine heat waves as well. Now, another important factor to monitor are co-bond events, where multiple events like sea level rise, storm surge, heavy rains, and flood a river can overlap and damage a city in the outlying regions. We don't know much about these kind of events. We don't have a quantified understanding. And for that, we need much more data and observations in the South Asian region. And how do we monitor and forecast these changes? We have the Sustained Indian Ocean Observing System. We call it INDOOS. I have shared a link to the full report comprising 23 chapters about the INDOOS report in the chat link. You can go through that. So these observations provide the sufficient data for forecasts and for monitoring agriculture, farming, water resource management, fisheries, and all. Now, because of sustained and improving this Indian Ocean observing system, we moved from the 1980s. If you look at, you can see the dots that are scanty in the Indian Ocean. There were barely any observations in the Indian Ocean, and we moved on to better design and observing status in the Indian Ocean with Rama moorings. These are moorings in the Indian Ocean, Argo floats, and XPT CTD lines and tide gauge networks. But still, there are gaps in this observing system, which is why we have recommended a redesigned new Indian Ocean observing system for the future decade, filling these gaps. But this needs strong regional partnership. There is a need for increased investment and stronger partnerships with the Indian Ocean Rim countries and end users, along with improved data sharing and commitments to best practices. Particularly, if you look at some of these regions, they are straddling the exclusive economic zones of these regions. So that needs strong partnership if you want the hydrological data of this region. One of the examples of regional partnership is the Rama Omni partnership between MOES, the Ministry of Earth Science, and NOAA, which happened recently, where the data from the Omni mooring arrays have been brought out to the public framework, along with the Rama mooring arrays. But similarly, we need to get or The way forward is that we need to have access to hydrographic data in the exclusive economic zones as well, because coastal processes are important. The monsoon processes are important for forecasting these extreme weather events in the Indian Ocean. And that's it, my folks. A lot of collaborators were involved in this work. You have Aditi Modi here, my co-presenter here from the Climate Research Lab at IITM. The Indian Ocean community is quite large. You should come and join with us if you are interested in these activities. And also, I have shared some of the work from the IPCC team and the UN Decade of the Ocean. Thank you. Thanks a lot.
Thank you so much, Dr. Roxy, for the very brief presentation. And I think it was really useful to know the ocean perspective in our climate science related studies. So I'm sharing the question answer slide, so where all the presenter can see the question and answer it accordingly. So Nico, do you have questions with you so that we can?
Mohammed, if you, the questions are in the question and answer window.
If you can.
Yeah,
Sorry,
go
Nico.
ahead,
Yes,
Helen.
I was just
go
going to
ahead,
say this. I was just going to say the same thing. We've got quite a few questions in the Q&A window, Mohammed, if you can see that, and people have liked them. So if you wanted to just start going through some of those.
Yeah, actually, the first question, as I mentioned from Dr. Krishnan's presentation, that it was sort of about the pollution in winter, so which impact like stubble burning and also like climate conditions also in previous years before. So Dr. Krishnan, would you like to say something on it?
Yeah, it's also in the previous. Can this be influenced by climatic changes? What?
Yes.
Okay. Yeah. Yeah, basically the air pollution, what we call as aerosols, the sources can be local. They can also be produced elsewhere and transported. And basically the North India, the Indo-Gangetic Plain, it's like a valley. So winter time, the temperatures are surface temperatures are very low, and the inversions are very strong. And these pollutants can both the local and the ones that are transported from faraway places, they can get trapped in the inversion. And some of the aerosols are like the absorbing type of aerosols. They absorb the incoming solar radiation, and they can warm the atmosphere. Whereas at the surface, the temperatures are cooler. So that makes the stability even stronger, and more aerosols can be trapped. So this is one of the reasons why the pollutants tend to stay for a very long time. And even the scatterers can make the surface cool. So it all is going to depend on how, I mean, if the surface is going to become cool and the stability is going to increase, then that's a problem. So that is precisely the problem that's happening.
Thank you so much. Our next question is from Dr. Tarao. It is on the statistical test. So what type of statistical test can be done in this case to show whether a 5% or any percentage increase and decrease in rainfall from climatological mean for the certain time domain is significant for or not for the it is, I think, for the Asian precipitation experiment related data. So Professor Rao, would you like to reflect on it?
I'm Terao, and but I think not to questions to my presentation. I think so. To whom? Is it clear?
Excuse me, if I may interrupt, I think it was part of the discussion that one of the attendees had with Professor Krishnan. So he had mentioned about a statistical significance test being needed to determine the drought and flood conditions.
Yeah.
Okay.
So, yeah. So the question is, I think first it started with a series of questions. Basically, the question is normally when we talk about drought in India, we look at the all India rainfall. That's about, if it is less than, this is a meteorological droughts. So if it is less than 10% deficiency, we call it as a monsoon drought. Now the question was, if you have a 30-year mean or something, how do you define the drought? So I didn't understand the question actually very clearly. And for anyway, in any case, if you want to do whether a precipitation decrease or increase is from the mean is statistically significant, you have to do a statistical test. That's my answer. And yeah, and in a more regional context, suppose we are looking at a smaller area, so the 10% threshold may not apply. You may have to go for, so normally for at subdivisional scale, we say it should be minus 20% the deficiency. Yeah, to call it a drought.
I think, Dr. Krishnan, there's another question for you, like why there is more warming in elevated areas like Himalayas than the plains?
That's I mean, the elevated warming, that is not fully, my understanding is it's not fully understood. There are multiple processes involved. It involves lapse rate feedback, albedo feedback. So it's multiple water vapor feedback. It's a combination of so many things. And there was a review article in Nature on the elevation dependent warming. So there they discuss all the feedbacks, why this elevation dependent warming is happening. So I just posted that reference also on the link.
Thank you.
It is not fully understood, this problem.
So there's another question from Professor Trau. How do you address the chaotic and uncertain behaviors of atmosphere in models used in Asia Pacific?
I see. So it is very interesting question. It's some difficult. And so that the behavior of the atmosphere and land interaction is very chaotic anyway. And so it's very difficult to catch anyway. It is true. But I think that very important thing is to get the scientific view about this chaotic system. So for that, we need to get real information from the interacting surface of the atmosphere and ground surface. So direct observation or the satellite observation was very important, but that the real scientific process has to be clarified. Anyway, it is chaotic, but we have to know it's chaotic process in the physical and the scientific way. It is our vision. Not so easy, but we should adhere to this scientific view anyway. So it is our my answer to this question. So maybe we can share.
Yeah. Thank you so much. I think we have answered all of the questions from this session. So back to Helen.
Yeah, thank you, Mohammed. And so we've got a few more minutes. So if there were any questions from, and I know I'm not sure if Mandira's online or not, but if there was any that we missed in the session 3, I think we could certainly take them now, but I'm just not sure whether it's going to be easy enough to find them.
Yeah, if Professor Dimri is online, he can explain more. I think elevation dependent warming, and he can.
Okay.
Yeah.
Professor Dimri, would you like to speak more about that? Professor Dimri, are you I see he's here, but I'm not sure that he can hear us. So there was a question also about ensembles that came up in session 3, but I just can't recall what it was now. Don't know if Mandira's here. If not, then we will actually wrap this session up unless anybody would like to ask any more questions.
Excuse me, Helen, if I can interrupt. There have been quite a couple of questions that have already been answered, but I guess it could be interesting to read it out to for the speakers to answer orally, because I think they could be interesting. So there has been a question for Dr. Sanjay on the dynamical downscaling.
Yes, I saw that one. Thank you, Hindamathi. Yes. So let's take that one.
So
who was that one for?
There's a question on the regarding whether there is any focused research effect to understand aerosol impact on monsoons. I just sent my response. Basically, I think our understanding of the aerosol impact on monsoons has improved significantly compared to, let's say, 15-20 years back. And this is reflected in the IPCC AR6 assessment on the water cycle changes. Still, many aspects are still not well understood. For example, the indirect effects involving the clouds and the aerosols, the microphysical effects. But I think we have a fairly good understanding of the direct effects of aerosol on precipitation. And this is summarized. And there are several activities going on, research activities. But still, I think many questions are still open. In fact, I mentioned in my PowerPoint also in my presentation that aerosol cloud interaction in warm rain processes is still an open question. Yeah. Thank you. Thank you very much.
Thank you. Thank you. And Hindamathi, the question that you mentioned, I did see it, but I can't find it now on downscaling. Who was that for? Can you remind us?
Yeah, it was for Dr. Sanjay from Sanaz Mungim. So it's a question. Yes, Dr. Sanjay, please.
Yeah, I have put an answer. So the question was actually whether the dynamically downscale products are available at spatial and temporal resolution. So the answer is that these are available at a 50-kilometer spatial resolution from the historical period, the second half of the 20th century, from 1950 till the end of the 21st century, as scenario projections, downscale scenario projections. And there was a sub-question in that actually whether there is improvement seen in the dynamical downscaling. I answered that also, that actually it's not seen everywhere, but in few regions and for few seasons, the evaluation studies which have come out of the Codex South Asia results have shown some added value in dynamical downscaling. That's all. Thank you.
Thank you, Sanjay. Yes.
Helen, we do have a few more questions coming in, which are still open. And so there is one from Ted. Actually, Ted is here attending the forum. So he has asked a question on the importance of regional forcings from aerosol changes in the region. So his question is wondering whether the local scientists feel that existing information from climate model ensembles is adequate or is somehow missing.
Yes, thanks, Hindamathi, and thanks, Ted. So I'm going to open that to any of our speakers that would like to answer it.
Yeah.
Krishnan, looks like he's going to. Over to you, Krishnan.
Yes. Thanks, Helen. Yeah, I think, as I said, we have a good reasonably improved understanding of the direct effects of aerosol on precipitation on the monsoons. But the indirect effects are, still many questions are open, and scientists are aware of this. And in fact, in our institute, we conducted a program known as the Cloud Aerosol Interaction Experiment for Precipitation Enhancement. It was known as SkyPix. And that brought out some new insights into the aerosol microphysics and the aerosol cloud interactions. But this is still a very topic that requires much more research, enhanced research in the coming decades, and how to represent them in the models. Recently, there were a couple of papers which I saw in Science, but the topic is still, it's a hot topic. That's what, an open topic for research.
Yes, thanks, Krishnan. Sorry, I spoke over. Who that was?
I think there was another question from Dr. Krishnan. It was on, you mentioned in your presentation that climate models do not properly capture extreme events in this region. What is the physical reasons?
No, which one? Which question is it?
This is from Shaukat Ali.
Yeah, I'm not able to see it. Can you please read out the question? I'm not able to.
Yeah, it says, you mentioned in your presentation that climate models do not properly capture extreme events in this region. What is the physical reasons?
Yeah, see, one of the reasons is, in general, I think the statistics of the heavy rainfall, the models are able to capture. Because with more warming, you tend to get more water vapor, 7% per degree warming. And this leads to more convective events. They're getting the statistics. But now if the rainfall intensity is something like, about 60, 70 centimeters a day, or sometimes even 100 centimeters a day, meter of rain in a day, which happens, and models just don't get them. And with increasing resolution, probably are doing a better job, because the higher moments you are able to get in addition to the mean, with higher resolution, you can improve the representation of the extreme high precipitation events. But even a model like, a 12-kilometer global model, one of our colleagues was saying, the Kerala 2018 heavy rainfall and flood, the entire state was flooded with the floods were covering the entire state. It was widespread. The one-day forecast was just not able to reach nowhere near the amount of precipitation amount. So that, I think that's still an open problem. How do you get, maybe we can get we'll get an ensemble, by doing an ensemble experiment, we'll get a probability of how much heavy rainfall we can happen. But these rainfall amounts are really way higher than what the models can do. So that's the problem, I think. That's one of the big challenges. How to get this heavy rainfall in the model. And also the location, when you add location. So is it, first of all, is it a reasonable question to ask these models to do this job? That is itself is a first question, I would think. Asking a climate model or a weather prediction model to predict 60 centimeters of rain or 100 centimeters of rain in a day. I think that's a very tough question.
So Mohammed, if it's all right with you, I might take the host's prerogative here, and in winding up, sort of coming to an end for the session, but I know that Ted had his hand up and he has posted another question. So I might actually go to that question if it's all right. And then once I've read that out, I want to come back to this precipitation. Is that okay with you, Mohammed?
I was thinking to ask the last question from Dr. Sanjay on.
Okay, all right. No, that's good. Yeah. You do that. Yep, please do.
Yeah, he mentioned in the abstract he's shared, like on the convective scale permitting precipitation. Yeah. So would you like to explain a bit more? We know it, but for the general audience, it will be useful what you are doing in it and when you are planning some experiment.
Yeah, actually, this is a Codex flagship pilot study project, which is other than the standard Codex runs, which are generated and disseminated on the Earth System Grid Federation, which have been used for uncertainty analysis and all that. But here, to get a better understanding of some of the problems, the regional climate issues, which we have not understood, like our Himalayas and the Tibetan Plateau region and all that, we have to get a better understanding of the regional water cycle and all that. So which needs, because of the complex topography and the associated complex weather phenomena there, even our regional models performance need to be improved there. So this project is looking focused on that kind of activity over the Tibet, over the third pole region, which is the Tibetan Plateau and the adjoining Himalayan regions, to do a model intercomparison study, specifically using models at a very high resolution, that is convecting permitting simulations, which try to resolve say systems like mesoscale convective systems, which are at a smaller scale than the standard resolutions used in the codex, like 50 kilometer or 25 kilometer grid space. So here we try to avoid the convective cumulus convection. Usually in these models are parameterized. That is, we try to see the effect of these things using the large scale variables like temperature, wind, and all that. So when you go to very high resolutions like beyond 10 kilometer, say in this studies we are using 2 to 5 kilometer resolution for the models. So you are explicitly simulating the cumulus convection. So you avoid the errors due to the parameterization of the cumulus convection. So these are just research, pure research studies. And currently what the initial experiments have been done is for a case study for a mesoscale convective system, which moved over the Tibetan Plateau and into the eastern Tibetan Plateau and onto China region. So that case study is attempted with different regional climate models, which can run at that high resolution like WRF, the weather research forecasting, and the REDCM model. We have used REDCM model. And there are some more contributions coming from other European institutes, which the initial results have been presented in the recent workshop. I showed the link there. So please see the project website. You will get more details of how this activity is going on. So we are one of the modeling partners in that activity. That's what I was trying to present.
Thank you, Sanjay. Over to Helen, please.
Thank you, Mohammed. And I think we went slowly there, and then we had a rush of questions at the end, but I will have to bring them to a close. So I just wanted to say two things, or actually three things, in rounding this off. Firstly, if you are somebody that wants to know more from one of the speakers, please ask them a question, preferably in the Q&A. But people are looking at chat as well. And I didn't get to ask Ted his second question, but those of you who spoke, those of you who are experts, might like to see his question, which is about the change in confidence in mean precipitation changes in the Southern Asian region between CIMOD 5 and 6, and whether there's anything that tells us what some of those reasons are. So if you want to answer that in chat, that would be good. And I just wanted to also say that one of the things that's a live discussion in WCRP right now is actually whether we want to do some more focused work around precipitation and prediction of precipitation. So this part of the Q&A has been really informative, and I just want to thank all the speakers on this session for a really informative set of presentations. Yeah. So I'd like to now go, because I'm conscious that we're going to run out of time. Sorry, Krishnan.
Thanks, Helen. I'm happy to answer that question.
Okay, you want
Shepherd about the CIMOD 5 and CIMOD.
Sure. Okay. Well, let's take another minute or so and answer the question, Krishnan. So the floor is yours.
One of the reasons is in the CIMOD 6 models, the detection attribution experiments have been done very, very nicely. That has, the attribution part is come out very well, and there was the DAMIP experiments were specially constructed, and so it has come out very clearly that many regions, the aerosol impact on the precipitation comes out, what happened in the historical changes in the monsoon precipitation. And also we have longer observations now, and different monsoon regions, West Africa, South Asia, East Asia, Australia, Maritime Continent, South America, North America. Attribution of human-induced changes in water cycle and precipitation is very robust in the sixth assessment compared to the fifth assessment. That is one point. mainly because of the models have also improved and the DA-MIP experiments also were very carefully designed. So that is one of the main reasons.
Thank you, Krishnan. I appreciate you answering that one. So I'm going to share my screen now because we've come to the Slido poll, which we'd like to go to. So pop over to Slido and start answering these questions about, so the Lighthouse activities are the explaining and predicting Earth system change that Dr. Wang spoke about in this last session, the My Climate Risk that Chashi spoke to in session 3, Digital Earths, sorry, Safe Landing Climates, and the WCRP Academy. So do you think that they're addressing critical science questions for the coming decade is the question that's there. So forward too quickly. So I don't know, are they live, Hindamathi? Because I'm not getting any update on my screen here.
Yes, Helen, normally, no, I think, yeah, I'm putting it live now, sorry.
That's all right. Sorry, I'm just trying to go backwards. Yes. There we go. So one person might have answered 4. Just give you a chance to keep answering those. I realise we're going to start losing people if I take too long through these, so I might just go to the next one. How could we improve? Yes, more inclusive. That's one of the things that we realise we're in at the moment is consulting with our broader community to build ways of people getting more involved in our lighthouses. So I think that's a fair comment. Yeah, it's hard at the moment. We would all love to get into a workshop in a room. We could all talk. Virtual doesn't always work as well, but that's a fair point too. I'll just go through these. We can always go back. Do we think the explaining and predicting Earth system change lighthouse is addressing the needs? So we've got a few people responding on that. That's good. And thank you, Dr. Wang, for your presentation on that lighthouse activity. It's good for our community to know more about that. Oops, that's it for the questions. So let's just see. Yep. Okay. Well, we'll keep this open for a little bit longer, and because I would like to actually come to the final session. So we'll just keep that open till the end of my next set of slides in Dumathi. And so this will be, I'll just to let our timekeeper know, this will be about 10 minutes that this will last. So I'll come to that in a moment. I just, before I go to the slides that I prepared, I just wanted to reflect a little bit on what we've heard. This forum was entitled Research Priorities for the Coming Decade. And to some degree that reflected some of the work that WCRP have done to develop some new science initiatives that we thought are important priorities for the coming decade. But it was also a title to reflect that through this forum, we wanted to hear from people, researchers and stakeholders in the region about what they saw as the priorities. So we've heard rich content from both our sectors and stakeholders and from our scientists with their deep expertise. We've heard, I mean, I've learned an enormous amount about the drivers of climate in this region, and that's been really, really good to hear. And we've had some great presentations on those processes and on the impacts of climate variability and change. Reflecting on this point about priorities then, you know, I think of Krishnan's talk where he identified 4 areas. As he said, they weren't the only 4, but these were 4 that were top of mind for him, about weather and climate extremes, monsoons, the Indian Ocean, and he said Indian Ocean sea level rise, but Roxy, of course, pointed to the other important role that changes that are happening in the Indian Ocean and the impact that they have on the ecosystems, coral reefs, productivity and so forth in the ocean, but the effect that warming has on the weather and climate over land, of course, as well. And then the Himalayan cryosphere, and we heard from Dimri about how important those impacts are in the region. And we then heard from Professor Toro about the new experiments and the new studies that are being done on Asia-Pac. So, I think these are some important scientific priorities. That sort of takes me to another thing that I heard about the importance of predictability across space and timescales. We heard just in that last Q&A about rainfall. And then when we're thinking about the climate information that's used by people on the ground to better understand hazards in the short term or do planning in the longer term, this point that Dr. Pai made about impact-based forecasting, I think is really important as well. And the role that we need to have in co-design and around communication. So I think, to my mind, I heard those, they came out around some of the priorities. And then there's observations. And Roxy talked to that in terms of the oceans and the importance of regional partnerships. And this brings me to the role that WCRP can play. The science that gets done is done by all of your institutions and agencies and researchers. What we can do in the WCRP is play a role to connect you with the science that's going on amongst and other researchers in the region and facilitate coordination. So, I'd really, after today and any follow-up we might have, think more about the role that WCRP can play. But today you did hear about what we're already doing through Cordex. Thank you, Dr. Sanjay, for describing so nicely what Cordex is doing. And Cordex has a very strong presence in all the regions. We heard a little bit about GWEX, but about Cleugh from Roxy and their role on the oceans. And we've heard about some of our lighthouse activities. So you have had some sense, I hope, about some of the activities that we're already doing. And in this last few slides, it's really to provide an introduction perhaps to how we can try and engage more with those of you who are perhaps not sure how to engage with WCRP. So let me go. So those were just some reflections from me about what I've heard. I'll go now to a couple of slides that were prepared before I heard the presentations, and a couple of these are repeats from what I spoke about in session 2, that we are keen to find ways to work with our sponsors, our partners and national agencies to support your needs. And we're already doing that. We work closely with WMO is one of our co-sponsors, of course, along with the International Science Council, who are oversight many of our academies and national agencies. So we're already engaged, but maybe we could do more in this region. So, we're keen to explore that. And the way that engagement, it could be, and I've said this in session 2, working with you to jointly identify new research areas that are important, or maybe there's a specific challenge in your region, in your sector, that we could better direct our scientific expertise. And that's going to be through our core projects and our lighthouses and so forth. So we're keen for feedback from you about how we can work with you. And sort of the same idea, but in a different way, we're keen to hear from you about, well, what more might we do in the engagement sphere? We are open to suggestions about follow-up forums like this one that are focused on a Pacific research theme around some of our core projects or lighthouse activities, or other ways that we can engage with partners and sponsors to strengthen those partnerships, explore research priorities that are mutually of interest and benefit, and co-designing research. The third dot point here is really important to the WCRP. If you look around any of our workshops and forums, you see a lot of grey hair. Many of our scientists are getting older, and we need to make sure that we're bringing through our early to mid-career researchers, not just to continue the research, but they're going to be the leaders of the future as well. So finding ways to better engage with early to mid-career researchers. The Young Earth System Scientists is a group of early career scientists in Earth System Science, and WCRP works very closely with them, and indeed our rapporteurs are from that YES community. And so, you know, if there's more that we can do to facilitate that, we're keen to hear about that too. So again, in closing, this is the same slide as you saw before. This is how you can connect with us. And just while you dwell on and on that slide, I just want to very much thank, firstly, all of our speakers. I think all of the presentations were really interesting, really on target. So I really appreciate the effort that you went to on behalf of us all to present to this forum. Thank you to our chairs who did a great job as well. Many of you in the chat have asked about whether the presentations will be available. This recording, this video will be made available on the WCRP website, but we will check with the presenters after the forum is finished, and if they are okay to share a PDF of their presentation, we will make that available as well. And lastly, therefore, I need to thank you, our audience. We've lost about half of you now because we have gone, you know, right to the end of this forum, but thank you for your interest and engagement with the forum. There is one more Slido poll, but I'm going to come to that after this thank you slide. So I've already said all my thank yous. This last survey will be open for 24 hours. So you can stay on now and answer the questions, or you can come back into Slido. You know how to go there now and answer them in the next while at your leisure. So I will finish now by thanking you all again, and I'll just bring up survey 3. I'll run us through what the questions are, but if you need to go, that's fine, because that is the end of the forum. So this question is about, you know, how inclusive do you think we're being in terms of reaching out to the full diversity of our research community, whether it's nationally, whether it's in terms of gender or career stage. So, you know, we want your thoughts on that. And that's just a yes/no answer. But the next question requires perhaps a little bit of thought about, we're keen to know, well, what more could we do to address any shortfall that we have in diversity? So if you've got a view on what some of the barriers are to building a more diverse group of researchers and across our community, and some ways that we might have to overcome these, we're keen to hear. We can't promise we'll be able to do all of them, but we're keen to hear what things we could do that might make a difference. So that might take you a little while to think about that. So you've got lots of time to think about it. We're keen to find out how we can increase our participation from researchers in the region. So there's quite a list of things here. If you could rank them from 1 to 4 as most important to least important, that's helpful for us to think about what more we might do by way of a follow-up in the region. And if there's anything else that we missed that you think might be a good way to build participation, just let us know. It's just an open text answer there. If we were to have follow-up forums, let us know what sorts of things would be of value to you. Please don't give us a whole long shopping list. Think about, you know, the top 3 or maybe 4 or 5 topics that you think would be very valuable for a forum. That would be helpful for us. And in this one, you know, as I said, we're very keen to think about the role that the WCRP plays in making a difference. So, you know, one person said absolutely number 1. So, you know, you can see we've got many 2s. Anyway, that's right, don't worry about that. Providing better coordination, providing leadership. You can tick on any of these, I think. Providing climate information at the regional level. It's interesting that we've got, you know, quite a focus on this regional information now through our My Climate Risk, through Codex, and through the new Regional Information for Society core project. So we're keen to get feedback on that, targeting user needs and addressing them, supporting training, and anything else that you think could help make a difference. And we're keen to find out what you're involved in. This is useful for our data, just to see across the different regions which areas of our work build engagement in the region, and anything else where you would like to be involved. How could we improve communication with you? Everybody tells us, and every research international program is the same, that communication is really important. We don't want to bombard you with emails. So, you know, what's the best way to communicate with you? What would be useful and meaningful for you? Tell us, we're really keen to know. And I think that's the last question. So if I can get my computer to talk to me, here we go. So I'm just going to go back up to the front of these to see. That's great, thank you. So just keep typing in. This will stay open for quite a while. So I'll just go back up to the thank you slide, and thank you all, and wish you a good evening, afternoon, or morning, depending on where you are. And thanks for joining the forum.